Welcome back, everyone. This is Michael Gibbs. I'm the founder and CEO of Go Cloud Architects. And today is day 4 of our free AWS Certified Solution Architect Associate 2022 boot camp. In this boot camp, we're going to cover the AWS Certified Solution Architect Associate. And realistically speaking, this is a free AWS certification training course. It's a full free AWS course, and it's designed to help you in your cloud architect career. We will give you AWS career trips, but realistically speaking, everything we're doing is about to help you get cloud hired. Again, I'm going to be here with my good friend and fantastic cloud architect, Alonzo Coleman. And any labs that we do today will be via Alonzo Coleman. Alonzo Coleman is a great cloud architect, but he also has a pretty good cloud engineer skill set, and that's why he's going to be configuring these things for us, because we architects, as a rule, we don't configure, but we definitely do our job in design. So realistically speaking, this is an AWS full course tutorial, and we're really excited to have so many people participate. This is day 4 of the process. So today, we're going to be talking about AWS network performance optimizations, and it's something that's going to be near and dear to my heart. We will also cover things from the internet protocol realm, such as DNS, and we're going to do everything we can to help you in your cloud computing career. This is day 4. I'll make sure that in the description below all of these videos, we have the playback links for the AWS Certified Solution Architect Associate 22 course, day 1, day 2, day 3, and day 4. So I want to make sure that you're all here. We'll, realistically speaking, kick off on the content in about 1 minute. All that I can tell you is, typically speaking, we come online and it takes about 4 to 6 minutes for YouTube to realistically inform everyone to come here. So bear with us for 2 or 3 minutes. If you did not have the opportunity this morning, I had Christina Marinaro, the CEO of IT Excel. That's a recruiting firm I've worked with for 20 years now. For 20 years, they've been helping my students get cloud architect jobs, network architect jobs, network engineer jobs, cloud engineer jobs, blockchain jobs, systems admin jobs, and every possible job you can think of. So if you did not see, the interview this morning with Christina Marinaro, I strongly suggest that you actually watch it. Give you guys some information on some of the cool stuff we're going to do next week. Next week, we're going to be bringing in on Friday my good friend Praveen. Praveen is a big data architect and a cloud architect. He's now a working cloud architect. He was my student, but he's been working in big data for decades. So he's the expert when it comes to creation of data lakes, working with data, gleaning data so that businesses can make much better decisions. So if you're here and you're ready to go, hit the like button, put hashtag cloud hired in the window, and we're going to have a really great time working on this AWS Solution Architect certification in our free AWS certification training. So let's go. Let's have some fun. Let's talk about some AWS network optimizations. And I'm super here to be with you. Have anything to kick off the conversation, Alonzo?
Well, as always, I'm always glad to see everyone from all corners of the earth coming here within our community to learn something really learn some really cool stuff, and just cooperatively just support one another at GCA. So let's go. Let's enjoy this. Let's get going.
Let's enjoy it. And if you're having a great time, please make sure you subscribe. Please tell others about this free AWS training we're doing. And let's do everything we can to get you cloud hired. Now, we're going to talk about some network performance optimizations, or at least what AWS calls network performance optimizations. So we're going to begin, and in this section, we're going to talk about a few things. Most of this is not networking, but AWS calls it network performance optimizations. Networking to network architects like me are as follows: routers, switches, cabling, and all the associated protocols that work in these environments. But some people loosely group a lot of non-networking things like load balancers into the conversation. So we're going to be doing this. So let's have some fun. What we're going to talk about in this optimizing performance and networking section is the following: placement groups, single root IO virtualization, otherwise known as PCI pass-through, and I'll show you what that really is. It's not so complex. We'll talk about the elastic fabric adapter. We will talk about DNS, or the AWS branded version of DNS, which is Route 53. And we will talk about load balancers and load balancer technology. And then, of course, we'll talk about the AWS branded load balancers. But we will always cover the tech first, because I want to teach you how to drive a car, not give you a certification for how to drive a Honda and then force you to go back and learn how to drive a Toyota for another training class. I want you to be able to work on any cloud, anywhere, anytime. So we're going to always look at these things from an industrial perspective as well. The first thing that we're going to talk about with regards to actually improving your performance is something called placement groups. So I want you to think about this. When we're dealing with networking, there's always going to be a time that it takes to go from point A to point B. That's called latency. There are applications that are very, very latency sensitive. I've worked with financial applications that 1 nanosecond can be the difference of hundreds of millions of dollars per year in terms of profitability. 1 nanosecond. Just that can enable a bank that's using an algorithmic trading system to process a trade faster than the rest of the market at a lower price. So when we're talking about high performance computing, we are talking about high performance applications, and reducing latency is essential. So in some cases, your requirements for latency are so low you can't put them on the cloud. In other cases, because it's too far away, you can use the local zones that we talked about because it's closer to you. In some cases, you can put your applications on the cloud and do things like placement groups, which is what we're going to talk about now. So placement groups are how you group your servers. That's it. So if you put your servers closer to each other, guess what? There's going to be less latency. If your servers are farther away from each other, there'll be more latency. But there are trade-offs associated with each thing. Often when you're dealing with high performance computing clusters, everything has to be really close to each other. So now understand that, and we'll talk about it in the term of placement groups. Placement groups are really about getting your stuff closer together to reduce the latency in between things. So let's talk a little bit more about the first kind of placement group. This, if you need to reduce your latency in the cloud, and you need your servers to be a part of this low latency, high performance computing cluster, this is the fastest, a clustered placement group. Here is what a clustered placement group is. You take all your assets and you group them together closely. Now, typically speaking, when you're using a clustered placement group, all your servers are going to be in the same rack, and in many cases in the same physical server. So think of this. If you have a 128 core server with 4 terabytes of DRAM and it's your server, and you put 4 virtual machines in the same server, look at what the networking is. It's not even leaving the server. It's literally speaking, the virtual machines will go straight from machine to machine in the same server. It is really fast. Now, by comparison, think about spreading your servers over 10,000 miles. Lots of latency. So a clustered placement group is when you put everything on the same rack and often in the same server. Now, think about this. Everything is now in the same rack, next to each other. So here's what it's going to look like architecturally. It's going to look like this. All your stuff, all your servers are all going to be in the same rack. So same rack means same switch, which means same power supply, which means if the power supply or the power distribution unit for which the servers are plugged into the rack goes down, poof, your systems are down. If they're all in one server and the server goes down, all your systems are down. So if the switch that everybody's plugged into or the power goes down, it's down. So clustered placement groups, high performance, no redundancy. So if you're going to use something like a clustered placement group, use 2 of them, one in one availability zone and another in availability zone. When it comes to high availability, 1 is none, 2 is 1, and 3 is greater than 2. If you were going to survive in the wilderness, don't bring 1 flashlight, bring 2. And guess what? If you have the opportunity, bring 3. So that way, you know you're going to be solid. Now, if clustered placement groups is putting all your stuff in the same rack, guess what happens? How could you do a little better? Maybe, just maybe, instead of being in the same rack, you could put all your things in the same data center. Maybe they're 50 feet apart from each other on different racks with different switches with different power supplies. Now let's think about this. Huge boost in terms of availability because it's still now not on one server or one set of racks or one set of switches. Huge improvement. But if anything happens to that data center or availability zone, you're down and you're out. So think about it this way. Partition placement groups give you the opportunity to spread your load across the data center. And remember, we're dealing with high-speed connections. We're dealing with fiber optic connections or copper connections. The speed of light is 186,000 miles per second. The amount of latency to cross a data center is in the nanoseconds, provided your gear is good. So again, this is still fine. Remember, keeping in your data center, not on the cloud, will reduce latency by milliseconds as a rule. So, what we're talking about here is to save nanoseconds. You can save milliseconds by running a hybrid cloud and keeping your things in the data center. So we're always talking about performance optimization. The goal of some of these optimizations is to get the cloud to give you the performance of the data center, things that you could do with the data center. But remember, the cloud is virtual data center, and anytime you virtualize, you reduce performance. So the cloud performs not as well as a properly best designed data center, but it is so agile that it is worth it. The cloud is the greatest thing to happen to us. But when we're in the cloud, what we have to do is often think, how do we work around the cloud? How do we architect the cloud solution to be good enough to meet the kind of performance that we were able to give our clients in the data center? Remember, Amazon's running their cloud in their own data center. They have access to the most performance. They resell capacity to us, which is great. Azure does it. Google does it. Palo Alto does it. The cloud is great. But remember, you got long cable connections, so it changes things. So clustered placement group, everybody's in the same rack. Partition placement group, everybody's in the same data center across racks. So much more redundancy. Here's what we're talking about with regards to a partition placement group. See? Spread across racks in the same data center. So hope that kind of makes that obvious to you. Now the next option, and this is going to have some pretty significant impact on it, is something called a spread placement group. What is a spread placement group? Basically, you spread your stuff across hardware, racks, and even availability zones. So much more availability, but also much higher latency. So you have to look at this as what is in the best interest of the customer. In most cases, a clustered placement group is going to be too risky unless you run two. A spread placement group will have lower performance, but it has high availability, so it may be a good thing. Here is what a spread placement group looks like. You're across racks and across availability zones. So relatively good performance because most availability zones are close to each other, and at the same time, you've spread the load. Much more redundancy. Now we're going to talk about some networking improvements, and we're going to use some industry jargon, and then we're going to explain what it actually is. So the next thing is what AWS calls enhanced networking. VMware coined the term single root IO virtualization. I don't know who makes up these terms. Here's what single root IO virtualization is. You take a physical network card, like the kind that's plugged into the server, and you pass it through into your virtual machine. So normally speaking, with virtualization, you've got your server, you've got a hypervisor, and the hypervisor creates, virtual network cards and virtual CPUs and virtual memory and virtual hard drives carved out of your physical server equipment. And that's, virtualization. So virtualization uses software-based network cards, software-based video cards. And here's the thing, things done in software are slow. Things done in hardware are fast. So if you had a virtual machine And if you've ever set up a virtual machine with a type 2 hypervisor, like something like VMware Workstation or Oracle's Dropbox on your computer, you know that in the virtual machine, the graphics performance is terrible. Why is it terrible? It's terrible for the reason it is a software-based video card, not a real video card. So we're talking about the same thing. If you had to do machine learning in a virtual machine like a GPU optimized instance, what they do is they basically take the video card, which is PCIe based, and they push that PCIe card directly in the virtual machine. And that gives the virtual machine access to a hardware-based video card. So it's the same thing. So what we're doing is we're calling it PCI pass-through. What is PCI pass-through? Is when you take a physical network card and you make it available to the virtual machine. If you make a physical disk available to the virtual machine, a physical video card to the virtual machine, it is the same technology. It's called PCI pass-through. You're passing a physical PCI card into the virtual machine. So AWS Enhanced Networking is nothing more than PCI pass-through, where you actually take like a 10 gig or 100 gig network card, physical card, and you enable it to be working within the virtual machine. That's it. Single root IO virtualization, just hardware card in your thing. You want to know what a GPU optimized instance is? Same thing. GPU pushed into a virtual machine. Now, AWS has another higher performance networking card. So right now we're talking about high performance physical cards with the single root IO virtualization. But with this case, we're actually talking about another software card. So what AWS has come up with a virtual network adapter that's got a really good driver behind it. So what happens, for those of you that don't know, you've got a driver which sits in between the CPU itself and the operating system, and it tells the operating system how to use that physical device. So AWS has created a really nice network adapter that theoretically has been designed for speeds of upwards of 400 gigabits per second. That's right, you heard me. 400 gigabits per second. It's not able to do that right now, but that's what the card driver is supposed to be able to do. So when you need high performance in your networking, you can enable single root IO virtualization, or PCI pass-through from another name, or you can use the virtual fabric adapter, which is a specialty high performance network adapter and driver to give you good networking performance. Now we're going to get into DNS next. And DNS is kind of a heavy topic. I am not Mr. DNS, but I've worked with DNS a lot. We're going to get into some pretty good depth with regards to DNS. We're going to put our geek hats on with the multiple propellers, and we're going to have fun with it as we go along. So I think we're going to stop real quick, answer some questions for the next few minutes prior to moving on to DNS and load balancers. So let's talk a little bit. Let's go through the questions. Let's see what we've got. Chris, if you'd like to bring up some of the questions so far. I can't seem to see what's... Okay, the first question. What are the use cases in real world to use a placement groups? I mean, when do you use it? Great question, Chintan. When are you really dealing with these things? There are times people run certain Hadoop clusters or Hadoop clusters that need to be relatively low latency, although they typically work well in the cloud. It's typically these financial applications that are super low latency. And I'll give you an example as a programmed algorithmic training platform. So when I first worked with this, it was about 20 years ago with one of the largest market makers on the NASDAQ. And what would happen is they had built a black box trading system. Now they're everywhere. And what would happen is the black box trading system had a history of various news. What happened on certain dates throughout history. It would have various knowledge of, what would happen if an earthquake would occur. What would happen, for example, if there was good financial news? What would happen if somebody released earnings? And then these black box trading systems would buy or sell large blocks of stocks based upon news feeds or financial feeds, what's going on with the industries based upon an algorithm. Now, when you're purchasing stocks for institutional investment, if you go buy a block of 1 million shares of Cisco, when you try and buy the block of 1 million shares in Cisco, what happens is you're bidding for an auction and it raises the price. Now, once you go to buy 1 million shares of, say, Cisco, for example, I just made up Cisco because I worked there and loved the company for many years as I worked there. So let's say you're going to do that. Everybody else is going to see that you're buying, and they're going to say, wow, this big bank is buying 1 million shares. What do they know that I don't know? So they all start buying. And what happens if the stock was $50, by the time everybody starts buying, it's $52, $53, $54, $55. And if you're going to go buy 1 million shares of something, $5 is $5 million. And organizations like these banks will do 1 million shares 30, 40, 50, 60, 80 times a day. They'll go through this with stocks. They may be smaller numbers, but they're buying, selling constantly. In these algorithmic systems, what they'll do is if they can buy it 1 nanosecond faster than the rest, they can buy it cheaper than the competition. So you buy a stock 1 nanosecond faster than the competition for 3% less. You let the competition then bid it up 5%, and then you sell it. So realistically speaking, these organizations are making 5% in seconds off of somebody else's money. So when you're dealing with these kind of low latency applications, the faster you can process a trade, the greater the competitive advantage. So there are a lot of industries where being first to market and making the first decision on an algorithm can mean billions of dollars a year in terms of additional profitability. So that's an example, Chintan, high performance systems that are doing algorithmic training in the finance world. It's not most places, but it definitely exists there. Chris, if you want to bring up the next question. Faisal, can you please talk a little bit more about virtualization and how it works? Absolutely. Bear with me a second. Let me see if I can pull up a slide to try and explain it to you. And other than that, what I will actually do, if I can't find a slide, I will just verbally do it. But let me see if I can get a slide that will verbally make it a little easier for you to see. I think I have a slide presentation for this.
I can also share the link to the video if you'd like.
Share the link to the video, and then I will basically go answer this question because I think it's a great question. But please share the link of the video of virtualization in containers. Great, Chris, thank you. So let me go back to this slide here. I'm going to get it here, and then let me paste this slide in because I think it's a great question. So let me go share my screen to answer your question, sir. So what is virtualization? Virtualization is as follows. You take a physical server, and why am I covering this in depth? Because virtualization is the enabling and driving factor of cloud computing. All your computing on the cloud will either be in a container or on a virtual machine. So here's what we're talking about. You take your server, which is physical hardware, and there's a layer of software you put on it. It's called a hypervisor. So what happens, let's say you've got this server, it's got 128 cores and 4 terabytes of DRAM in it. You then install a hypervisor. What the hypervisor does is it enables you to chop that computer into that physical server into multiple logical servers. So the hypervisor is a memory manager. It is a CPU manager. So what happens, you take this server, and on your server, you install the hypervisor. And then after you install the hypervisor, you create your virtual machines. Now, in each virtual machine, you specify your CPU, your memory, your hard drive space. Then you launch the virtual machine like any other virtual machine. You install an operating system on it like Windows or Linux, and you install your application. So virtualization, which was really the foundations and the fundamentals of cloud computing, we started using about 30 years ago in networking. Today's virtualization has roots, actually IBM about 50 years ago, and then 30 with the mainframes, they had some virtualization. And then after the mainframe virtualization, we had switch virtualization and VLAN virtualization about 30 years ago. And then we had private VLANs, which are the equivalent of a container. But what we're talking about here is a physical machine for which a hypervisor has been installed, in which case you create multiple servers on a single server. And while we're at it, even though this isn't really part of the curriculum, but it's necessary for you to get cloud hired. So we'll talk about containers and we'll talk about virtual machines. So now we're going to have a container. So let's go right back to this real quick. Here in a virtual machine, you've got your server, your hypervisor, and note you have multiple virtual machines, each with their own operating system. Now, because each virtual machine has its own operating system, the operating system takes a lot of space. It may take 20 gigs, it may take 40 gigs of RAM just to run the operating system. So virtualization is the foundation of cloud computing. All your EC2 instances, Azure virtual machines, Google Compute Engine are all virtual machines following this philosophy. Now, there is a newer technology for virtualization, and this is called containers. Again, containers are not new. We had a concept in networking 20 years ago called private VLANs, where you would have 2 users in the VLAN, and basically they couldn't communicate with each other. Well, this is the same thing. With a container, it's much more lightweight. We still have our server just like before, the same physical server. But here, say we install Linux or a host host. Then we install a container engine like a Docker or Kubernetes. From here, we make these little lightweight isolated things that basically the app and the libraries that are necessarily needed. So while a virtual machine, you've got your users, you've got the hypervisor, and you've got separate machines that all have same different operating systems. When you're dealing with a container, you're dealing with the server. The server's us, the container engine, and then you've got these little mini logically isolated applications all in their own containers. The containers are logically isolated. So theoretically, if container 1 crashes, it should not affect container 2 or container 3. And that's how these work. So virtualization gives you the most security because everything is completely isolated, but it takes all the most overhead. By comparison, containers, which are a lighter weight form of a virtual machine, each container leverages the operating system of the host. So if you can put 20 virtual machines on a 128 core server with, say, 4 terabytes of RAM, you might be able to put 200 containers on that same server. So containers are a lightweight approach to virtualize your applications and take your applications from point A to point B. So I hope I answered your questions there with regards to what is virtualization. The hypervisor is basically like a Linux kernel and a little bit of software. So that's the best way I could describe it. So are there any other questions, Chris, before we move on? I want to make sure we answer everybody's questions and we give everybody a great experience. Any more questions, Chris? Okay, Srinivas. Hello, sir. What is a GPU? What is the use of this? Great question, Srinivas. A GPU, or a graphics processing unit, or a video card, is a card that's been optimized for graphics. Now, graphics processing is often used by consumers with regards to video games, but graphics processors are really powerful. You could be dealing with like 20 teraflops of performance on a GPU. So what a lot of organizations are now investing in is GPU computing. Instead of doing your computing on the central processing unit, you do your computing on the graphics processing unit. CPUs are very fast, like a race car. GPUs are like a tractor trailer. They're a little less fast, but they can do 1,000,001 things at the same time. You may have 128 cores in your CPU, but you may have thousands of cores in your GPU. So when you've got parallel computing, your graphics processing unit is incredible. Where do we use a lot of graphics processing units outside of video games? Video rendering for movies basically takes straight what do you call it? Footage that comes straight out of the camera. It comes raw footage, and we convert it to like an MPEG-4 with maybe an H.264 or an H.265 codec to really shrink it down. We use GPUs for that kind of rendering. We also use GPUs for machine learning. Here's the reason why. We take all this information, and the GPUs are powerful enough. For all the ML and AI things, we're predominantly using GPUs. There's a little bit that can be done in fully programmable ASICs, but for the most part, it is GPUs. So GPUs are used for a lot of things: video editing, graphics performance, and data science and machine learning AI applications. Okay, let's the next question. Noel, so with containers, are you doing away with having to use a hypervisor? Absolutely not. You can provide substantially more resources to a virtual machine. You can have a virtual machine with several hundred CPU cores and terabytes of DRAM. But you know what you can't do? You can't make a container like that. You've got a lot of memory and CPU limitations with regards to your containers. Really big environments will need virtual machines. Big servers need virtual machines. Some things that are lightweight can be deployed in a container. So it's about knowing what to do and choosing the right one at the right time. If there's no more questions, I will go back to the content. Just want to make sure at periodic intervals. Okay, if you're still here and you're having fun, if you could hit that like button and subscribe if you're not a member. And guess what? If there's others you feel like that would be helped by this, please share the link to this so they can catch up. They can start from the beginning and continue to watch. And let's get back into the content. So now, yeah.
You've had a request to explain a hypervisor again.
Okay, we can re-explain the hypervisor. I'd be more than happy to do so. Let's go back to this slide, and we'll go back over here. So let's talk about this hypervisor. The hypervisor is a layer of software that will partition the physical hardware in your server to allow the creation of virtual machines. Chris, do I have the ability to share a web browser?
Yes, you do.
Okay, so let me do this. Let me log into one of our servers.
Use the screen share function on StreamYard.
Okay, I'm going to try and figure this out. Okay, proceed. Let me go log into one of my servers. Okay, everyone, let's do this. You guys asked a question way outside of AWS Certified Solution Architect Associate training, but totally critical for cloud architect training. So let me do this. So, oh wait, I might be on the wrong browser in order to be able to share this. So let me try this one more time. 192. Yeah, I know this isn't. Okay, so we got a StreamYard. It says share, and then what do I do? Share screen. Share screen. Okay, I see. Oh, great, Chris. Thank you so much.
And then someone else asked about Kubernetes. Would you like me to direct them to the video?
Yeah, for the Kubernetes, direct them to the video. But I actually will. Can you guys see my desktop right now?
On OBS, make yourself big.
On OBS, make myself big? Excellent. Okay, so you guys can see me. And you see if you guys can see the server. Can you guys see my server? And the server screen? Okay, the answer is yes. So here we are. Excuse me, we're in a VMware ESXi server. This is one of the servers that my students use to build clouds, to learn cloud computing, to set up virtual machines, build containers, they build their firewalls here. And of course, they build a cloud because, to be a cloud architect, you really should know how to build a cloud. So now let's look at this physical server for a moment. Note, you can see the manufacturer is Dell. It's a Precision 2810. You can see that I've got 24 CPU cores. You can see that they're E5 2670 V3s. You can see there's 128 gigs of RAM here. You can see this is the server's IPv4 address. You can see this is the server's IPv6 address. You can see these DNS servers. They happen to be Google's DNS servers. You can see the default gateway or its router and the such. Now you can see right now that the CPU is used at 2%. The memory of the server is being used at 34.5 gigs, and we've currently used 660 gigs out of the 1 terabyte drive here. So now let's actually walk through the creation of a virtual machine so you guys can know what goes on behind the scenes at AWS. Now, if you go to Azure and get a virtual machine, if you go to Google and get a compute engine instance, then with AWS, if you want an EC2 instance, it's this. Same thing, but they pre-made it for you. So here's what it is. So we've taken the server, we installed our hypervisor, which is just this software. We're then going to create a new virtual machine. Let's say we name the virtual machine. We'll call this AWS. So I know how to delete it afterwards. CSA 2022. And then what we'll do is we'll tell it the guest operating system. Let's say we select Linux. We select
Mike,
yes.
can you zoom in on the browser some?
I can't zoom in on this because it opens up in a short window. But I'll zoom, and my browser is 100% zoomed in. Unless there's something else you're talking.
You can zoom to 125, 150. If you go to the three buttons to the top right corner, zoom. There you go.
Okay, excellent. See, what happens is Mac users that haven't used Windows in 20 years until their Mac couldn't handle their needs have to learn how to use Windows. Seems to be working pretty good, by the way. I was really surprised after not using it for decades. So let's say we suggest Ubuntu 64. And then next what we'll do is we have to customize the settings of the virtual machine. Note, CPU. We select the number of cores. This is going to determine the performance of the system. Number of CPU cores and the clock speed of those cores determines your server power. Then, we want the hardware going directly to the guest. There's some coders. Then we would select the memory of the virtual machine. What's the memory? It's the DRAM. So I select gigs, and then I choose what I want to use. I want to use 16 gigs. I want to use 8 gigs. You select the amount of memory that you use. Then you select the network adapter. Now, you can do status of these things. You can create a MAC address if you needed to match something. And guess what else you can do? You could do single root IO virtualization or pass through a card, but I don't have any extra cards in here. Then typically speaking, when you launch a computer, you launch the server from a CD or an ISO file. So here we go. We'll do that. Now, then we've got to go to the data store and find the operating system images. So here's where we keep the images. I don't even know which image this actually is, this Linux ISO, but we'll just pick it. We'll select it. We'll go to next. We'll go to next. Now, here's a window, a machine that we just tested. Let's boot up that system. Okay, well, I don't think I actually set up an appropriate operating system for that. So let's power this system off. This is what happens when you do things live on the fly. Like I said, I didn't recognize that operating system. So, so let's go back to this. Let's edit the settings of this virtual machine. I don't really like that data store's ISO file that we picked because it's apparently not our right thing. So let's go to let's go to the data store. Let's go find out where here we go. Let's go find an operating system file. Now let's launch that virtual machine. Note it's going to launch like any other Ubuntu server because it's a logical server. It's virtualized sitting inside of this thing. So if any of you guys have ever set up Ubuntu Linux, we've just now created an Ubuntu Linux virtual machine. So what we did is we took our server. The server has a hypervisor. The hypervisor enabled us to take the number of CPU cores, memory, and DRAM. We've selected that. We've mounted an operating system. And right now we would install the operating system on this server identical to the way we would do it on any physical hardware. Note, when you're doing it this way, you actually have to install the operating system. It's not going to be like with AWS where you just click 3 buttons and it can be done. You have to know something to do it this way. You have to be better. And that's why, employers are looking for virtualization experience. That's why we train so much. You must know this. It is an absolutely, absolutely critical skill. You must have extreme knowledge on server virtualization to be working as a cloud architect because everything that we do, 100% of everything that we do is we take things from the network and the data center and we move them to the cloud with equivalent services. And in order to do that, you must know what it is you're actually moving. Let me delete that so we don't use the resources on the server. So are there any more questions on server virtualization before we go back to the content?
Someone asked if we know what hypervisors AWS uses.
AWS uses their own hypervisor called the Nitro hypervisor. Realistically speaking, all of them are almost the same. They all either come from VMware's ESXi, which typically speaking runs on a Debian Linux kernel, or what you're typically finding is all of these other hypervisors are all running on Linux for the most part, whether it's KVM, which is the common Linux one, whether it's QVMU, which is also a common Linux one, or whether it's the Nitro one, or whether it's Xen, it doesn't matter. It's just a hypervisor. So, hope we answered your questions here. We're trying to give you everything that you need to be cloud hired. So if you're having fun, hit that like button and type cloud hired, and we'll go back to the content. Trying to give you everything you want and need all at the same time, in addition to just giving you what's necessary for certification, because getting certified versus cloud hired are very different. So you guys all ready for DNS? Let me know by typing cloud hired and smacking that like button. Okay, very good. I see you guys are enjoying them. We'll always have some bonus content. We had we're planning on doing a database demo today for you as well. But whatever we can do to get you cloud hired, to get you cloud skilled, to improve your cloud architect career development or your technical career development program, that's what we want to do. We're here. That's why we don't focus on certification. We focus on cloud hired. So thank you for letting me know with the cloud hired. Thanks for hitting the like button. Please share. As my good friend Sandeep says, sharing is caring when it comes to producing free content and training others to have the best career. Let's please spread the word. Let's please share this. If we could all share this to 10 other people, and there's thousands of people on this call, we can really help a lot of people live better lives, have better financial health, and be able to take care of their families in a much better way. So help me support this mission by sharing. Let's give people what they need to be able to achieve what they desire. So let's talk about DNS. What is DNS, or the domain name system? The domain name system is somehow to map a name, a user-friendly name, to an IP address. You don't need DNS at all. DNS is a convenience. If you knew the IP address of every single computer in the world, you would just connect to these computers via IP addressing scheme. That is it. DNS is used to make life easier, which is going to be easier to remember. gocloudcareers.com, or an address that is an IP address. And I'll tell you what our IP address is, because I don't even know right now. But let's do this. So I wish it would be harder for you to remember. NS, so let's do an NS, hold on. NS lookup. Okay, so which would be easier for you to remember? 192.0.78.137. Would that be easy to remember, or would Go Cloud Careers be easier to remember? I can remember Go Cloud Careers. I've already forgot the 192.0.78.137. It's only been 3 seconds. So if you have a photographic memory like my wife, and you have the ability to remember everything, you don't need DNS. But for the rest of us humans that have memories that can't remember everything, we need something that's user-friendly. So DNS is used to map a name that we can understand to an IP address. www.cisco.com. So easy. Amazon.com. We could connect to the IP address, but who could remember it? So realistically speaking, I want you to really see what's going on here. So when we're dealing with DNS and we're mapping names to IP addresses, let's say you go to your computer and you want to go to Amazon.com. So you go to your web browser, you type www.amazon.com. Your computer then sends a request to the DNS server. The DNS server says, here's the IP address for Amazon.com. It gets sent to your computer. Your computer caches that information or stores it for a short period of time, and then connects to the IP address. See, we're connecting to the IP address, not the name, but it's the name that we use as an intermediate step. So DNS mapped a name to an IP address. Now let's talk a little bit more about DNS, because it's super important. If you go to your computer and you want to find the IP address of any website on the internet, all you have to do is do an NS lookup, or name server lookup, and then type in the address. You can see here, I did an NS lookup of www.amazon.com. The first thing you can see is my DNS servers, which are Google's DNS servers, the 8.8.8.8. And when you see this pound 53 or hashtag 53, it's them reminding you that it's TCP and UDP port 53 that is used for DNS. Port 53 is used for DNS. I'm going to say it again. Port 53 is used for DNS. You want to know the IP address port on your exam? It is port 53, TCP and UDP. Coincidentally, Amazon has a DNS service, and they call that Route 53. Where's the 53 come from? It comes from the UDP TCP port 53. So now let's go back to my NS lookup of Amazon.com. First, you got the answer. And the answer is that Amazon.com, the real name is this address, this ugly looking tp.47.cf. That's realistically the CloudFront distribution that's being used by Amazon. Or the two sets that are there. But what's going on is Amazon's got what's called the CNAME record, which maps a user-friendly address to this ugly CloudFront address. And that way, what's going on is you can find it. What is the IP address for Google's CloudFront distribution that we connect to? At least at the time I did this video or made this slide, it was 13.35.116.114. That could have changed since now and then because they could have changed servers, changed addresses, and updated their DNS policy. But as you can see, the DNS map is www.amazon.com to this address of 13.35.116.114. Made it real easy, huh? You know exactly where you're going all the time. So let's get out of this and let's talk about the parts of the DNS system. See, we're going to discuss DNS before Route 53. It's part of that. Let me teach you how to drive as opposed to let me teach you how to do AWS. You need to be able to work on every cloud, everywhere, every time. So let's talk about DNS. Domain names are broken into a minimum of 3 separate sections. We're going to have a host name, we're going to have a domain name, and we're going to have a top-level domain. Let's break it down. Host name, www. Domain name, GoCloudArchitects. Top-level domain, .com. So www.gocloudarchitects.com is what's called a fully qualified domain name. Why? The www focuses the host. The domain name is GoCloudArchitects. And the top-level domain is .com. Lots of top-level domains. .net, .edu, .co, .uk, .gr for people like me and head over heels. We would have a .gr or Greece that are attached to it. So see, it really doesn't matter, but you have to understand what's going actually on. You've got an alias record that's mapping one thing to another. In this particular case, whether you call it a CNAME record or an alias record, you're mapping some ugly thing, mapping a name that's familiar to something that's not. So I am not Mr. DNS. I am a network architect. These are typically done by the Unix Linux admins, but DNS is important, so you must actually know this. Let's talk about DNS record types. When we're going to be dealing with the cloud, we're going to have DNS records. DNS records, which are also known as zone files, realistically speaking, give particular instructions about the DNS servers that are going to provide the information for the domain. And it's going to use this specialized form, which is known as DNS syntax, which basically is a text file. And it's going to tell the DNS server how to carry out its actions. Anytime you're dealing with DNS or caching or a lot of these things, you must have a time to live. Because if you just had a name mapping to an IP address that never timed out, if you needed to change the address, it would never update. So your DNS records are going to have a time to live. It's normally measured in seconds, but it can be changed. There are a massive type list of DNS records, and here we're going to talk about the most common ones. The most common ones that you need to know are as follows. The A record, which simply maps an IP address to a name. The 4A record, AAAA, that one you realistically need to know. Why do you need to know it? Because it's a simple A record, but for IPv6. A CNAME record, which is what we talked about before when I talked about taking a friendly address and mapping it to that ugly CloudFront distribution DNS address. It's a CNAME record, a canonical name record. Some people used to call something like it an alias record. It's not exactly an alias record, but it maps a domain to another domain. You must have an MX record if you want your enterprise to receive email. NS record is the name server record, pretty important to know. SOA, or start of authority record, is also important. SPF, or Center Policy Framework, you probably need to know. So we'll talk about it. So when we do this, now let's talk about the AWS branded version of DNS. It's called Route 53. Route 53 is the AWS implementation. We've been discussing DNS in general. Why have we been discussing DNS for general? AWS is not the only game in town for DNS. You can be using the AWS cloud in your own server, your DNS servers in your data center. You could be using Google's DNS servers. You can be using anybody's DNS servers, F5 DNS servers. So when we talk about AWS and we talk about DNS with regards to AWS, we're talking about Route 53, but it doesn't have to be anyone's. Now, Route 53 is a highly available service. It's high availability, high latency, and it's very good. Now, Route 53 uses something called Anycast. And Anycast is a very challenging concept to learn, but it promotes high availability. Here's what Anycast is. Anycast is when you have multiple servers that all use the same IP address. And now you're saying, wait, Mike, you told me yesterday that every single IP address in the world needs to be unique to have communication. And that is still true. You will not have true communication unless every IP address is unique. Anycast is a rule to break the rule, but the rule still applies. Here's what Anycast is. I have 10 servers located throughout the world, and every one of them has the same IP address, which is a problem because what's going on here is they all have the same IP address. Now, these servers all are synchronized with the same information. Now, what happens and the way this actually works is as follows. I'm here in my house in Palm Beach, Florida, Port St. Lucie, Florida, right near Palm Beach. Life is really simple. I'm playing with my computer. I'm going to my nearest DNS server. What happens? I want to go to cisco.com. I go to cisco.com. I do a DNS lookup. My DNS lookup uses the Google DNS servers, which are 8.8.8.8. Now, I get a response from 8.8.8, and I know what to go, exactly what we told you. But how do I find my 8.8.8.8? My internet service provider is running BGP, and they're exchanging routes, going back and forth in all these different directions. They're exchanging routes. So when I go to my internet and I look for the DNS server 8.8.8.8, what's going on is my internet service provider is giving me the closest 8.8.8. Now, should that 8.8.8 go away, guess what? My internet service provider's routers will find me the next 8.8.8 that's the next closest, whether it be because at some point it had the better local preference, shortest AS path, or however the traffic was engineered. So what happens with Anycast is you've got multiple devices that are using the same IP addresses. And what happens if one of these things goes down, the routers on the internet will know how to reroute your traffic to the next server with the same IP address. So look at it this way. Since Anycast is way, way, way above the scope of the Certified Solution Architect Associate training, critical cloud architect training, but we could spend weeks on optimizing Anycast and using it for multicast and other things. So this is not a small process, but Anycast basically is multiple servers, all the same IP address, and the routers take you to the closest one. And because of that, if a DNS server fails, guess what? You just go to another DNS server and another DNS server. So we're really talking about some good performance when we use Anycast DNS. Now, I'm going to cover a few of these records that I want you to know. The A record. Let's go to it this way. The A record is simple. It maps a name to an IP address, and for IPv6, it's an AAA record, maps a name to an IP address. Simple, elegant, that's all you need to know. Now, the next record is called a CNAME record. What's going on with a CNAME record? It's similar to an alias, but not exactly. A CNAME record is when you map a domain to another one. So if everybody that goes to www.a.com gets automatically forwarded to www.b.com, that is a CNAME record, and you need to know that. When you're dealing with CloudFront, you will almost exclusively be using a CNAME record, because CloudFront, the content delivery network, is going to give you the ugliest URL for your website, and your users will never remember it. So you're going to have to make a CNAME record to map a cool name, a human usable name, to the CloudFront distribution. Now let's talk about the NS record. The NS record, a very critical record, identifies the name servers, the authoritative name servers, the ones that are responsible for your DNS zone. So these are the servers that propagate your official DNS information to the rest of the DNS servers on the internet. See, this is important. The next is an MX record, which is a mail record, which specifies which mail servers can accept mail for your domain. After that, we'll talk about the start of authority record. This is the primary name server for the domain, the responsible party for the domain. Realistically speaking, it's a timestamp that changes anytime you update your main domain. So let's talk a little bit more about the AWS implementation of DNS called Route 53. It's designed to be a relatively low-cost method for DNS services. Route 53 with AWS supports IP version 4, which it has to, and IP version 6, which is the future. You can route customers inside of your AWS, outside. It's just a DNS server. So Route 53 uses health checks. We'll talk a lot about health checks, but health checks enable you to determine if a server is healthy. I'll go do and give you my generic answer of a health check. Here is what a health check is. Let's say you've got 3 web servers and you want to know there. You're going to have a health check, which is going to ask your servers, are you there? Are you there? Are you there? And if the servers are there, they're going to say, I'm here. I'm here. I'm here. So if the querier or the DNS environment is saying, are you there? Are you there? Are you there? And you don't get a response, DNS knows the web server is dead. And do you want to send your traffic to a dead web server? The answer is no. So the DNS servers will just literally remove the dead server. So that's what's going on. With these health checks. You've got a query that says, are you there? Are you there? And you get a response that says, I'm here. I'm here. Kind of like an OSPF hello, where they used to say, hello, 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 every couple of seconds. It's how you identify your neighbors. That's how you keep high availability. So that's how it all works. So hope that made sense to you. So now let's talk about using DNS policies. See, when we're talking about the domain name environment, we can route our traffic accordingly to many different things. Since we're talking about the AWS implementation of it, we're going to describe the AWS implementation. But guess what? It's not much different if you're on Azure. It's not much different if you're on Google. It's not much different if you're on in a data center and buy a really good DNS setup from F5. It's the same. So we're talking about DNS, not just an AWS service. So let's talk about the kind of routing policies you can do. And you need to know most of these. We'll talk about simple routing. We'll talk about weighted routing. We'll talk about latency-based routing, failover routing. We'll talk about geolocation routing, multi-value answer routing, and geo-proximity routing. Wow, that is an alphabet soup. That is a mouthful, but you need to know these. You will see them on the AWS Certified Solution Architect Associate exam, the AWS Certified Solution Architect Professional exam, but most importantly, you need this for your cloud architect career. The whole point of certifications is to help you get hired in the end. They are 10% of the process to getting hired, but you still need to focus on them for that 10%. They can help you get that interview. And once you get that interview, it's up to you and your technical competency, your communication skills, executive presence, emotional intelligence, etc. to get hired, but they help. So let's get you the information you need to know. We'll begin with simple routing policy. Simple routing is as follows. It is very, very, very simple. Simple routing does the following. It maps a name to an IP address. That's it. So map this name to this IP address. Perfect, simple, elegant. Now, traditional simple routing, that's what most people think of DNS. But that's not it. We've got more policies. Now, this next policy is really cool to me. It's called weighted routing. So when you're dealing with weighted routing, you can tell how much of your traffic to send to a different location. This is cool. Why do I love weighted routing? Well, let's say you want to try a new website. You don't know if it's going to fly. You don't know if it's going to work. Think blue-green deployment. So you send 10% of your users to the new website and 90% of your users to your current website. If you send them to the experimental website and you get lots of feedback and lots of orders and the customers are saying, I love this, it works, then you just shift your policy and send everybody else to the new website. So what's going on here with regards to weighted routing is you specify a policy, 90% here, 10% here. So really great way to test new software. Excellent way to do it. Send 50% to Azure, 50% to Google, weighted routing. So this way, you know how to set up policies that are going to work for you in your environments. If it's Route 53, it's going to work across the internet. If it's your own DNS servers, it's going to work on the cloud. DNS is a standard, so not that much of a complexity. Now, the next thing is called latency-based routing. Latency-based routing is kind of cool. Latency-based routing is as follows. Part of the service to giving a great user experience with web-based applications is as follows. It's getting the user to access the content as fast as possible. So, what slows the content down? What slows the experience down? A lot of it is the latency between you and the ultimate destination. They can be far away from each other. So let's say I work for a company that's got a website in London, a website in Lagos, Nigeria, and a website in San Jose. And I want to get to the computer. So I go to my www, and what happens is the following. My system determines the latency from my location to the web server, and it sends me to the web server with the lowest latency. So it may send me to California, San Jose, or it may send me to London. It's probably not going to send me to Lagos, because to get to Lagos, it's a lot further away than it is from San Francisco for me. So latency-based routing is about sending you where the latency is lowest for the best user experience. Now, the next type of DNS policy we'll talk about is failover. I use a lot of failover routing in my design. Failover routing is this. Send it to this server or data center. And if that server or data center is not there, send it somewhere else. So think of it this way. You've got a hybrid cloud environment. You've got an organization that's running an OpenStack Ansible cloud or a Nutanix cloud in their data center. Their data center is really well built. It gives them ultimate web performance, far better than in the cloud, at a cheaper price, because they are really top notch. But they don't have disaster recovery. So in the disaster recovery environment, they're using a cloud. They've got small instances of things running in the cloud with an auto-scaling group. All their data is copied to the cloud. Here's what happens. DNS detects a failure over the data center. The DNS redirects the traffic to the cloud. Auto-scaling within 45 minutes, scales out, adds all these servers, and the customer's data center is up and running on the cloud. Fully operational with low cost all year long, and it will be there exactly when the customer needs it. So failover routing could say, hey, AWS is my primary, fail over to Azure should AWS go down. Failover routing enables extremely good options when you're doing things. The next one we're going to talk about is geolocation routing. This is kind of cool, and I want you to think about it. Let's say you're in a part of the world where about 6 languages are spoken. Kind of like where I'm from. I'm a Mediterranean person. In the Mediterranean, we speak Greek, we speak Hebrew, we speak Arabic, and of course we speak English. Typically speaking, those are the majority of the languages that are spoken in the Mediterranean. Also, you've got some Italian and some Spanish, but as well, most of the Mediterranean is in that hybrid between you're dealing with Israel, Greece, and the Arabic nation. So you've got those languages. So let's look at geolocation. Imagine this. I'm in my house in Nepetamos, Greece, and I go to the internet. It detects my location and sends me to a Greek page in Greek. I'm then in Israel, and it offers me 2 options, Arabic and Hebrew. I'm now in Dubai, and it sends me directly to the Arabic one. That's the power of geolocation routing. What happens is the user hits something. It looks at their source IP address, and it sends them to the destination best suited for them. So You've seen it all the time. When you're in China, you're in Hong Kong, you go to a web page and it takes you to the Chinese version of the web page. You go to London, you get an English version of the web page. You go to France, you get a French version. That is geolocation routing at its best. Now, the next thing that I really like talking about is multi-value answer routing, because to me, this is something that I can't imagine why anybody would use it, but it's comical to draw it. It's kind of like rolling the dice. You set up a policy and you specify a bunch of servers, and every time it just randomly sends it to somebody else. So I don't like random in my designs at all. I like control. Multi-value answer routing policy is simply this: go anywhere. So I can't traffic engineer around anything and random, so I don't use it very often. The next one and the last one we're going to talk about is geo-proximity routing. Geo-proximity routing is a bit of a strange concept, but it's kind of cool, and I want you to know about it. Here's what happens. With AWS, they enable something called geo-proximity routing. They divide the world into multiple regions. And basically speaking, there's this bias that you can put, and it will expand or reduce the size of the regions. By expanding or reducing the size of the regions, traffic will be placed in other locations. It's called geo-proximity. Never used it, but it's important to note what they're talking about. Now, let's go into health checks. Apparently, I'm Insta famous for my version of a health check. In fact, people just call me up and say, Mike, are you there? Are you there? Are you there? Which, if it gets people to remember what a health check, I'm all for it. I just want people to remember, whether you're on a job interview and someone asks you what a health check is, or whether you're taking that test, if you can remember, are you there? Are you there? You'll never forget the health check. So let's realistically speaking, look at that health check one more time. Here's what's going on. And this happens in all health checks. You've got the AWS Route 53 doing a health check. It's sending a message to the server. Are you there? Are you there? Are you there? Now look at what's happening. On the top, on the right side, we've got a server that's asked the question, are you there? And you see it responds, yes, I'm here. And that's why it's got a green check. Now, the bottom server, are you there? No. Are you there? No. Are you there? No. Uh-oh. I just kept saying, are you there? I've asked a few times. I've not got a response back. We have a problem. This server is dead. Remove this server from the rotation and only send your traffic to the green one. That's how we do it. That is what a health check is. And now you know. So hopefully when you see Mike's, are you there? Are you there? Now you know why. It's a health check. It's used with load balancers. It's used with DNS, and it's used absolutely everywhere. So we covered DNS. DNS is a big topic. Can't tell if I'm seeing things that are coming in. So if anybody has any DNS related questions before we go to load balancers, let me know. Otherwise, smack the like button and type cloud hired in the box. Okay, I see a question from Kishan Rao. How to configure simple DNS server custom DHC for multiple VCTs via transit gateway, peer, and hybrid. That is a great question, Christina Rao. How are you going to set up a config? There's a lot of ways you can set up a DNS server on and off the cloud. We could, realistically speaking, spend the next 6 to 8 weeks showing you different ways to do it. But here's the thing. We are basically teaching an architecture program. And as an architecture world, we don't do any of the setup. We do the design and other people's build it. People call it cloud engineers. We are actually doing some things. So if there's an ability and a desire to set up a DNS zone and configure some Route 53, I can add that to Alonzo's list, and we can have Alonzo do a DNS lab another day, because I think it would be good for you to understand how to set up DNS in the AWS environment. But, configuring complex things, that is an engineer world versus an architecture world. And as a rule at Go Cloud Architects, we train cloud architects. So we're more on the focus of teaching how it works. Having said that, that other course that we recommend when it comes to your certification exam, we recommend the 3 following. This course, because it's going to teach you what you need to know. Our book, because it teaches what you need to know. Additional resources of great information. Andrew Brown of Exam Pro has a great course, which has got a lot more of those hands-on kind of labs. because he focuses more on that certification piece, and it's there. So I recommend that as well. And I always recommend a practice exam prior to taking an exam. We love Review and Prep. Haman Sharma, their CEO, is a great guy. We have no financial arrangements with any of these people we've described. We just feel at Go Cloud Careers and Go Cloud Architects, we should give you the best information from everybody, whether it's us or anyone else in the world, so you have the best cloud computing, cloud architect job experience. Doreen, is Route 53 supernetting? Not even at all. Route 53 is DNS, which maps a name to an IP address. Supernetting is when you take 2 subnets or 3 subnets or 4 subnets and that are contiguous, and you summarize or you aggregate them together. So if you took a 192.168.0.0/24, a 192.168.1.0/24, a 192.168.2.0/24, and a 192.168.3.0/24, you could summarize them into a 192, actually there's 4 of them, right? Okay, so a 192.168.0.0/22 instead of 3/24. So it's kind of in those kind of things. So hope I answered your question with regard. MW Muru, does that mean that an AWS Anycast, all their servers have the exact same information and service? The answer is yes. All with the same IP address, all with the same information on them. And realistically speaking, in traditional Anycast, and you go to the one that's closest to you. AfriP, what can we do to ease the IPv6 migration implementation for the future? Oh boy, well, here's the thing. It's all related to your IP addressing scheme. So as you know, when it comes to designing a network, how you actually address your systems will determine whether you can route summarize. It will determine, what boundaries you can use and how you can set up your network. So IPv6, just like IPv4, is about planning the right subnets for route summary, route aggregation, and traffic engineering purposes. AfriP, this is a CCIE level question you're actually asking, which we're going to cover in a lot of depth in our Cloud Network Architect program, because we could spend the next 8 weeks with regards to IP subnet design, literally speaking, and still not even touch it. Abigail Marks, if you use a VPN to watch a British show, how is Netflix still be able to block you with an IP from that company? They shouldn't be able to if you set it up right. If you're really using a VPN and it's not a public VPN that just reroutes your information to nowhere. And what I mean by that is there's all these little personal VPNs that people actually use to hide their IP addresses, for example. When you're using those, what happens is millions and millions of users come out of those same IP addresses. So Netflix and other companies often block those addresses. But if you set up a true IPsec VPN, Abigail, between New York and London, you would basically get access to the UK page. But that's with a real VPN. But when most people are using these VPNs, they're blocked. Because like if you were to use the Tor browser, which sets up a VPN, and you wanted to go to YouTube, YouTube would basically give a warning, and it's going to say, hey, too much traffic coming from these servers, you're blocked. That's what's going on. In fact, I will tell you, when people work in other countries, often they use a VPN to bypass the rules of those countries. Like, for example, in the Middle East, direct internet access is not allowed. At least in Dubai, you go through a proxy server. There were people that were like, Mike, don't worry about it. Create a VPN. And I said, no, you want me to violate a country's laws? I don't think so, because they could do that to violate it. But it's not me. I go to someplace, I honor the rules, I honor the laws. But understand, VPNs do work, but the public VPNs that most people do, that are the consumer things, are just designed to masquerade your IP address, and most of those addresses are blocked. Okay, what is the difference between geolocation and geoproximity? Great questioning, Lightning DDD1. Geolocation is very simple and very logical. It determines your IP address, knows where you're at, and then sends you to the closest location. So if I'm in Greece, it sends me to the Greek webpage. If I'm in Abu Dhabi, it sends me to an Arabic webpage. If I'm in Saudi Arabia, it sends me to an Arabic page. If I'm in Israel, it sends me to a Hebrew page. If I'm in Mexico, it sends me to a Spanish page. So that's what geolocation routing is. Now, geoproximity is kind of weird. It's kind of like a geo area specific. You set up a bias, and AWS kind of does it. Much, 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 much more control with geolocation. I don't use geoproximity. I've never used geoproximity but geolocation is used by everybody when they've got international, multinational companies. Next question. Record sets are actually configuring things via Route 53. Maybe we'll have a Route 53 configuration section at some point tomorrow or the weekend. I'll see if it fits in with Alonzo's time frame. Any others, Chris? Okay, wow, great. We've answered all the questions and we can get back going. If you're having fun and you're learning and you're enjoying the concept, please smack that like button and type hashtag cloud hired in the box. And then we'll get back to talking about load balancers. We love feedback. We work really, really hard to put these things together. Hundreds of hours going to put together a certification course like this. So we'd like to know if you're enjoying it. Okay, now let's talk about load balancers. Load balancers are really cool. What do load balancers actually do? In fact, what is a load balancer? A load balancer is, quite frankly, simply a device that's going to distribute traffic amongst multiple other devices. That's it. A load balancer shares the load amongst multiple devices. So I want you to really think about this. Which is stronger, for example? One person or 10 warriors? One warrior or 10, all from the same team. Look at it this way. They don't send one SEAL, they send a SEAL team. Why do they send a team? More people equals more capabilities. No single point of failure. If you've only got one person and that person gets injured, they can't win. So they send a team. What do we do in tech? We take lessons learned from all kinds of environments. If you have one server and the server fails, you've got a problem. So you've got two options when it comes to servers. Let's say you're at a 64-core server and it's got 4 terabytes of RAM, and that CPU is 80% busy and the memory is 90% used. You could do this. You could go to a 128-core server with 4 terabytes of RAM, and then it'll be at 40% utilization. You're going to be great, right? You would. But would it be better to use 2 64-core servers with 2 terabytes of RAM or 128-core server with 4 terabytes of RAM? 1 is none, 2 is 1, and 3 is greater than 2. Remember high availability. So 2 servers for which you could lose one is better than having one server that could die. So a load balancer improves performance and availability. That is the difference of performance and availability. That's why organizations use load balancers. I'm going to say it again because I ask this in interviews and no one knows. We use load balancers to improve system performance and promote high availability. So what happens is the load balancer enables you to use 10 servers instead of 1. 10 times the capacity, and you can lose 9 of them and still have one up. That's why we use load balancers, to improve availability by removing single points of failure. Remember, you've got 2 options. Scaling up, bigger computer. Scaling out at a bunch of computers. So when you're dealing with scaling out, you're using a load balancer. The load balancer is a high availability tool, and it's one of your best friends as a cloud architect. So next, we'll talk about load balancers, but there's 2 kinds of load balancers. I don't care if you're talking about an Azure load balancer or if you're talking about Elastic load balancers with AWS. There are 2 kinds of load balancers for real, and there's another kind which is totally unrelated. When it comes to load balancers, you have network load balancers and application load balancers. Here's what I need you to remember. Network load balancers are fast. If you have any kind of high performance requirements with a load balancer, you will always use a network load balancer. A network load balancer operates at layer 4 of the OSI model. On day 1, or was it day 2, we covered a lot about the OSI model. Chris can put the link to that inside of the window in case you haven't seen it. Now, because network load balancers look at things in the header, source and destination IP as protocol and port number, and it's not a lot, network load balancers are not the fastest. Network load balancers don't have to have the most intelligence. So if you ask a computer to do a simple task as fast as possible, Boom, 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 boom. Now, if you ask a computer to do something complicated, okay, task 1, task 2, task 3, task 4. So while the network load balancers offer something's really, really, really fast, and we'll touch the gateway load balancer, it's kind of like a network load balancer, but that's neither here nor there. But if you ask it to look into the headers, so network load balancer is really slow, really fast and really dumb. TCP, UDP, protocol port number, that's it. That's why they're so fast. Application load balancers look at everything. They look at things inside of the HTTP, HTTPS header, you route with 2 microservices. They are really intelligent. If you ask a computer to do something complex, it is slow. So speed, network load balancers. Intelligence in your routing, application load balancers. And with AWS, they're going to talk about something called the elastic load balancer for the network. We'll talk about the elastic load balancers for applications. We'll talk about a classic load balancer, which is the same thing, just a network and application. Now, recently, AWS came up with the concept of a gateway load balancer. And the gateway load balancer, in many ways, is just the same as a network load balancer. Here's what a gateway load balancer is used for. If you have a real enterprise-grade security, you're going to need a real enterprise-grade firewall. And that's not going to be AWS's Wi-Fi Shield. It's going to be something from Cisco, something from Palo Alto, etc. Now, when you're using AWS Cloud Native services like an elastic load balancer, these are fully redundant devices. But in your VPC, you might need to use a load balancer that's not made by AWS for more performance. Or you may want to use a real next generation robust security firewall like something you're getting from Palo Alto or Cisco. Now, in the data center, this is not a problem. You get 2 Palo Alto firewalls, you connect them in, they have a heartbeat between each other and a hardware failover. Great. In the cloud, you can't do that. You can't plug in a really hardware physical server. So in the cloud, when you need, and this is with AWS, this is with Azure, this is with GCP, when you need something beyond the basic services offered by the cloud provider, you're going to go to the marketplace. So you're using a gateway load balancer to load balance between Cisco firewalls, or to load balance between somebody else's load balancers like F5 load balancer software, or you could be load balancing between things. So we used to use network load balancers for this functionality, and now AWS came up with something called a gateway load balancer, and it's designed to really load balance between things. So Marketplace is your friend when you're dealing with global enterprise solutions, and you need more than a WAF or a shield when you need that enterprise grade, that robust grade for end-to-end serious solutions. So now you know what a gateway load balancer is. It's just a network load balancer that's used to load balance between network devices. Part of this, we did things like used network load balancers to load balance between these things. So now they came up with a new one, and it's basically a network load balancer, but they call it a gateway load balancer. So now let's talk about the Amazon branded load balancers. Basically, they call them an elastic load balancer. If you don't know, if you have to guess on a test, stick the word elastic on it, and chances are you're going to win the question. So a load balancer, regardless of whether it's network, application, or gateway, are all called elastic load balancers in AWS. Or classic, but that's neither here nor there. Load balancers are IP devices. So guess what? They use an IP address. Guess what? Load balancers auto scale too, because a single load balancer won't be fast enough for everything in your career. So load balancers can auto scale. So if you don't have enough IP addresses in your subnet, auto scaling won't occur. So make sure you've got enough addresses. Now, load balancers are cool devices. They can load balance across availability zones. They can use health checks, and they can terminate SSL connections, which is really cool. So think about it this way. What you're actually dealing with is you've got a load balancer, and it's going to load balance in between multiple servers. Now, typically speaking, when I said that the load balancers can terminate an SSL connection, I want you to think about this. If, by comparison, you terminate the SSL connections on the server, that uses a lot of resources. Encryption is CPU computationally heavy. So if you can put the encryption and terminate the SSL connections on the load balancer long before we ever get to the server, we can reduce the loads. So let's talk about network load balancers. Network load balancers, as I mentioned, are really fast, millions of requests per second. Really great with rapidly changing patterns. Here's the thing. Don't ask your car to do too many things and it'll be fast. When you get in a race car, they don't even have air conditioners in them. They don't want to drain it. They have no luxury things like that. They don't have radios in it. They're basically trying to minimize it. So a network load balancer is the minimalist approach. That's why we use it for shared services. That's why we use it for big services. That's why we used to use the network load balancers to create elastic load balancer sandwiches and load balance between firewalls, prior to the gateway load balancer, which does basically the same thing. It's not exactly the same, but it's designed to support the same function, to load balance between various other devices. So network load balancers are really, really fast. Now, they're stateful. Why are they stateful? The connection between the user and the server is maintained until the session is completed. That means every time a user requests things, he or she is sent to the same server until their session is over. And a new user could be sent to a different server, and a new user can be sent to a different server. How is this achieved? If you look at what's going on in the load balancer, and it's mapping the source address to a destination address with a protocol and a port number, the load balancer has all the information. And remember this at the network layer. What happens is AWS calls this a sticky session, and it basically what happens is it keeps you on the same server, and there's a mapping of the source and destination connections, and that's how it works. Generally speaking, we use network load balancers for giant VMs like those with 120 cores, or shared service VPCs, or load balancing, other load balancers, or load balancing firewalls. Anytime you need high performance, you can actually route to containers with them, but most people don't. Let's talk about what it typically looks like. So here's what we're using a load balancer for. Let's look in this situation over here. In this particular, and I'll move it over a little bit so we don't have me in the upper right corner being a problem. We have a network load balancer across availability zones, and it's distributing the load to these web servers in 2 different loads. This is your typical use case for an elastic load balancer, network load balancer, application load balancer in either case. In this case, we're using a network load balancer because we're dealing with big and strong EC2 instances, and we want the speed. Now let's talk about an application load balancer. Application load balancers are really smart. They're working at layer 7 of the OSI model. Remember, I'm a network architect by trade. Well, actually, I practice medicine by trade, but that's neither here. But for a guy like me that spent the last 20-some years prior to cloud involved in designing networks for the world's largest internet service providers, banks, and other organizations, look at it this way. Where we're actually coming from is the perspective of the layer 7. This is not my world. I'm a layer 1 through 4 world. Application load balancers can look at the path provided in the URL, the elements based in the HTTP and HTTPS header, the HTTP method push or get, and routing between the source. So this is really good for HTTP and HTTPS traffic, micro responses, realistically speaking, and load balances on stateful connections. So really good. Let's look at what these look like architecturally. Architecturally, here's what's going on. You've got your load balancer. Your target groups could be groups of servers or a single server. Basically, your load balancer is listening and it's shedding the load. Now, note, we've got a health check going on here because we want to remove bad servers. So this load balancer, for example, is saying to these servers, are you there? Are you there? And they're saying, I'm here, I'm here. And the same thing is going on. The listener is what's doing that health check. Now we'll talk about a classic load balancer, and then I'm going to address internal and external load balancers because for whatever reason that has people confused. And I think it's the way people typically talk about it, but it's the simplest thing in the world to make sure everybody understands that. The old load balancers that Amazon has have called the classic load balancer. And guess what? They're network load balancers or application load balancers. And they call it legacy, and they auto scale, and they can terminate SSL connections, and they can still provide logs to analyze traffic flows. Guess what? old version of the same thing. Lots of these things are naming. A gateway load balancer does what a network load balancer does. And if you watch the AWS videos, every use case they give you is the same as the network load balancer. It's got a new name. But is it a network load balancer? They may have tuned it a couple percent. But here's the thing. It works just like one. When it comes to architecture, you need to know about what services can do what. So could you do it with the classic load balancer? Of course you can. Could you do it with the elastic load balancer? Of course you can. Could you bring in a virtual appliance from the marketplace from F5 and then use a gateway load balancer to load balance between the F5 things? Yes. Classic means older, but it doesn't mean it's any different. But AWS recommends you use the new version, the new branded elastic load balancer. So when you deal with a manufacturer, you read their documentation and you listen to their recommendations. They make their own stuff. So sometimes there's a little bit of branding and things to sound cool along the way. If that's the case, that's the case. But in many cases, guess what? Listen to them. Don't build something without looking at the documentation. Don't read something without looking at the documentation. And when we're talking about here, same thing. So classic load balancer, legacy version of the same thing. So now let's talk about internal and external load balancers. That has the whole world confused. Most people think of external load balancers. Here's what an external load balancer is. You should think of an external load balancer as an internet-facing load balancer. Or could still be an external load balancer for non-internet. An external load balancer is something that you use for basic, let's say you've got a set of websites and the exterior world comes to your website, you put a public IP address on the outside of your load balancer, and that is the public address for all your web servers for the whole world. External load balancers are used for external applications, like internet applications. Load balancers are used to improve performance and availability. So, most people think of external load balancers for their web app, but if you're working with organizations, do organizations have servers inside their organizations? Maybe they're running an electronic health record in healthcare. Maybe they've got HR software. Maybe they've got an intranet website that is not available outside of users in the corporate network. They still benefit from a load balancer. But instead of your load balancers having a public address and being directed to the outside world, your load balancers can also be used internal to your network to load share across other servers. So please understand that. Internal load balancers are just used for availability and performance of your internal privately addressed servers on your intranet. External load balancers are used for external applications like internet applications or partner applications. I hope that makes sense. We'll talk about a couple more things. They typically don't show up at the AWS Certified Solution Architect Associate level. They typically show up at the AWS Certified Solution Architect Professional level, but you need to know these things. And since you need to know these things, I want to address them. Let's talk about some things like listeners and targets and target groups and sticky sessions and health checks. Well, we talked a lot about health checks. So let's talk about listeners. The load balancer is going to have a process that's going to wait for a connection request. Application load balancers are going to look for HTTP and HTTP requests on ports 1 to 65535. That's what they're going to look for. Network load balancers aren't going to look at anything that heavy. They're going to look at TCP or UDP or TLS and ports 1 to 65535. So they're looking at a lot less. They're looking for things so they know where to distribute your traffic. Then the listener that's listening for the connection request will then send it to the load balancer. And the load balancer is configured with targets. Targets are where the application is going to send it. So if you've got 10 virtual machines, the target could be all 10 of those virtual machines. The target is going to can be a group of things, or it can be a compute instance or a virtual machine with an IP address. Now, if your target is an address, an IP address, it must be an internal IP address or a private IP address or something that's specified in RFC 1918 or RFC 6598. For those of you that are not familiar, the Internet Engineering Task Force comes up with internet specifications. They are specified in something called an RFC or a request for comments. RFC 1918 specified private IP address spaces a very long time ago, like 20 years ago or more. And it came up with the 10.0.0.8 10.0.0/8, 10.0.0.0/8 as specified for private IP addresses, 172.16.0.0/12, and 192.168.0.0/16 are specified in RFC 1918. Now, there's this new concept of the shared address space, which was specified by RFC 6598, and that uses the 100.64.0.0/10 address space that is also shared address space. So remember, if you're dealing with an elastic load balancer inside of AWS, you're going to be load balancing internally to something on the 10.10 address space, the 172.16/12, the 192.168/16, or the 164.0.0/10. You must be using one of those things. Target is a system. Now, what is a target group? It enables you to group your system together. So maybe a target group is 10 EC2 instances. Now, we probably also should talk about the concept of a sticky session. I had mentioned previously that what you're doing is the load balancer remembers the source and the destination and sends you guys to the right server. That's what we're trying to do. So that's what goes on. You get sent to the right server, the appropriate server, and you stay there. With a network load balancer, it's called a sticky session, and it happens by default. And it is really good and really cool. Awesome. Now, by comparison, if you're using an application load balancer, it's not that fast. I mean, it works a little differently. The application is tracking stuff and microservices, so it's not going to be super easy for your application load balancer to necessarily track this user's source IP address and this user's destination is where the traffic was done. But sticky sessions enable that. So with the network load balancer, this happens automatically. But when you're truly dealing with sticky sessions on an application load balancer, you need something more. So what happens is a cookie is used, and a cookie will basically be used by the load balancer to keep the traffic between the user and the specialized server the entire time. So those are the kind of things that I wanted you to just know, some last minute things. Now, we've covered a lot on DNS. We've covered a lot on load balancers. And we're going to start talking about some security concepts, which I think is really cool and fun. But before we actually do that, I want to make sure that we answer some questions. So, Chris, if you can bring up the questions.
There's a question that came in from somebody. I think they're delayed a little bit on their view from the previous section, so I'm going to pop it up.
Ruru, can you kindly give us an industry example of how you use one type of routing versus another one? For example, weighted versus latency. Absolutely. So, and I don't use a lot of latency-based routing, but I will tell you that weighted routing is constantly used. Weighted routing is as follows. Weighted routing is basically when you specify a percentage of traffic to go to one location versus another. Weighted routing is constantly being used when you want to deploy a new application. So a lot of times people will try and deploy a new web page. And what will happen is they want to test it on a certain number of users, like a blue-green deployment. You basically send 10% of your users to the new website and 90% of the users to the old website. And with the 10% of the users on the new website, you can get user feedback and find out if the website works. So that's typically MW Muru, how these things are actually being performed. Now, latency-based routing, for example, would be to make sure that your users get the lowest latency. I don't use a lot of it, but what would happen is your users would basically try and reach something, and their source IP address would be determined, and it will determine which website to send them to. It will improve user experience. I got to tell you, I use a lot of failover routing. For example, I have a lot of people that have really great hybrid clouds in their data center, and they want to fail over to the cloud, for example, and use the cloud for disaster recovery. I would also say that another great place where failover routing is used is you've got a multi-cloud environment. you've got your load on AWS, but you've also got a backup on Azure, and you could use failover routing where if AWS, your website on AWS goes down, goes straight to Azure. So there's lots of examples. For example, that weighted is commonly used, and failover is commonly used as well. I hope I answered your question, MW Mura, and if you want more, please ask more. I don't want to say that there's no different, but the use cases, the way you're using an application load balancer versus a network load balancer are pretty much the same. I'm also going to tell you that there's not much that changes between taking in things and distribute them amongst modes. So realistically speaking, if you're dealing with firewalls and you're dealing with network devices and load balancing between load balancers, we used to use a network load balancer. Now you've got the gateway load balancer. It's probably a better choice. Very similar in many ways and use cases to the network load balancer. When you watch the documentation from AWS, it feels the same too. FRP. How granular should the load balancing policy with the type of connection and request? FRP, the more granular you make things, the more complicated things go wrong. Generally speaking, the military adage of keep it simple, stupid is the best way to design these systems. So try and keep it as simple and elegant as you can. Having said that, there are times when you can't, and that's when you do it. But as a rule, I would at least say, with regards to the type of connection location, I would say figure out what's best interest for your customer. Meaning, is it best to be low latency? Use a latency-based rule. Is it best for failover? Is it best for blue-green deployments? I would say choose the policy that is appropriate for your organization and keep that policy, FRP, Mr. P, as simple as you can. Question, can you use a single application load balancer for handling HTTP and HTTPS requests? Well, as a rule, no, because you can't have single points of failure. Now, could you use a single application load balancer in the AWS environment to do things instead of policies? Sure. Here's the thing. They're theoretically highly available things. See, the point is you could get away with it. Babitas Nito, which one are you going to use to implement an internal load balancer? If you need speed, use a network one. If you need intelligence, you use an application load balancer. If you want to route in between routers or firewalls or things like that, which would typically not be internal, you would use a gateway load balancer. But nothing changes whether you're using a public IP address or a private IP address, Babitas Nito. It's the same. Same decisions. Krillov, how is a sticky session handled if we load balance an auto-scaling group that scales down? Could the autoscaler terminate an instance with an active session? Great question. I don't know, so I can't really answer that. Leonard Lash, what are the key features provided by an elastic load balancer? Leonard Lash, load balancers are the same as any other load balancer. Key features, so share the load across multiple servers, increase speed, performance, and availability. AWS has a list of features. If you need above that, you will have to go to a vendor like F5 and go to the marketplace. But for the most part, you can do everything you need to with the AWS load balancers. They're pretty rock solid. Can you use both a network load balancer and an application load balancer for an application? Well, for different parts of the application, of course you could. You could have one set of things for your web things and another set of things for microservices. Organizations will have 5 load balancers for a web app. They may have one for Mac users. They may have one for Windows phones. They may have an additional load balancer for iPhones. They may have another one for Windows users, another one for Mac users. Organizations have lots of load balancers. How do you combine DNS routing with load balancers to route users to a certain condition? Well, they're kind of unrelated. So DNS or domain name system matches an IP address to a name. So typically speaking, DNS is going to point to the public IP address of your load balancer. And then load balancers are going to route between your servers. So DNS is just mapping a name to an IP address. And you typically map to the address of the public facing address of your load balancer. But, realistically speaking, and they both run health checks. So what'll happen is as follows: DNS will query the load balancers, and if they're not there, DNS will reroute to somebody else, assuming you've set up the right policy. The load balancer runs its own health checks, and if you've got 10 web servers or 100 web servers, the load balancer will run a health check. Are you there? Are you there? Are you there? If a server doesn't respond, the load balancer will remove it, and then it won't send traffic to that. So basically, it's doing the same thing, but they're two completely separate entities. Derek Houston, routing policy question. How would you configure the router to restrict a domain to a website with a country of origin? Can only be, okay, so Derek, now you're talking about routing, and routing can be one of two kinds of routing. Traditionally, routing is based on routing protocols. So if you're doing it on the true routing side, don't advertise a route or filter that you don't reach inside your network, and it won't be reachable. The same by comparison, don't accept a route from some subnets and you won't be able to reach it. Now on DNS, you're setting up the DNS policy. For example, the DNS policy might basically say, go to this data center versus this data center. So routing policy is really determine where you want it to go to. So if I understand the second half of that question, Derek, and I'm not completely sure I do, but if, for example, I do run into a restriction, I run into a question with regards to hold on, how would you configure the router to restrict? Okay, so the routers really can't restrict countries of origin, but what you can do is you can actually, if you're using a router, you can filter out certain IP address ranges that are associated with a certain country, and that's how you could make it not reachable. Or you could do what other organizations do. So let's say you're in Dubai. In Dubai, they do not let you go to certain websites. You can't go to a website that has illicit things or anything that would be deemed illicit. So what does Dubai do? They push everybody through a proxy server, and the proxy server has a routing policy. So what's going on is you go to the proxy server, and the proxy server says you can't go to these sites, but you can go to these sites. So what happens is the proxy server sends you the appropriate location. So any other questions here? Derek, China has the Great Wall of China, which blocks all kinds of things. And when you're dealing with internet routing in China, it is really complex because there's so many government rules and regulations that you must work past. It's just so many. So many. So I was thinking security, but I also thought it could be a good fun chance for Alonzo to build a database with you guys. Do you guys want to do a database lab with Alonzo right now? Or would you like to go to security? Comment in the comment section below, and we will run this course based upon your desire. You want to do a fun database lab with Alonzo? Let us know. You want me to talk about information security and cloud security next? We're going to do it. We'll do whatever you want.
Alonzo's not fighting any. All right, database, lab, content, Alonzo, security, database. Looks like databases.
Okay, Alonzo, take it away. Why don't you run a database lab? Do that for about 15 minutes. Give everybody the chance to get a break. While you're at it, if you guys can smash that like button and comment and share. We always like to know you guys are having fun. Let other people know about it. So it looks to me like when we look through the list, it's database and then
database time. Okay, so, as a disclaimer, everyone,
we'll do security right afterwards.
Okay, yeah. As a disclaimer, we know that as architects, we're more architecturally focused on building as opposed to implementing. So with this database, we're going to do a very high level execution of setting one up. We won't be doing any query editing because it gets into the code and thereby development. So we're going to stay focused on what the concept of data, what the database is, and being able to set one up. So here we go.
I need my drum roll music.
There you go.
Okay, everyone. If you are following on your AWS Management Console, I'll give you just a minute or two to kind of log in and get focused, and we'll set it from there.
That timer was the minute timer, by the way.
Okay, well, there it is.
I'm just kidding.
We have to, hey, we got to follow what Chris says, go. So we got to stay focused. So, okay, I am.
Can you zoom in a little bit?
How's that for everyone? Is that okay?
There we go. I think that should work.
Okay, wonderful. Okay, so we are, as we spoke, we're going to be working on databases, and specifically, we're going to go into our RDS Management Console. And we're just going to set up a very simple, or rather, I'm going to follow through with what I've already pre-made for a database, as it takes a while to spin up the database cluster. So I'm just going to walk you through what I originally put forth already. So once you get to the AWS Management Console, you're going to click on to RDS, and you're going to arrive at the dashboard, okay? And we're going to create a database. So I'm going to switch my window already, as we've already went through this. So as a create database, my focus was on MySQL. It's very simple, and wanted to just create that high level execution. And we're going to move over to the next screen. So I've already, I guess I'll walk you through so that everybody is comfortable and understands what the execution is. So I pressed MySQL. SQL is a database. It is a structured relational database. And we put in the free tier so that we don't want any surprises, although I'm hoping everyone already went into their management console and set up their AWS budgets for experimental purposes. And so now we're in the settings right now. So what you want to do is that you want to make a name for your database. You want to name it. You want to make sure you associate it with what you need it to be. And for the credential settings, always like to keep it as admin, very simple execution. And you're going to create a very simplistic password for yourself so that you can access as the administrator into your database to make certain queries or make adjustments as necessary. You want to also confirm your password. And it says that right now because, I've already done it. So we're just going through again, all the checklists and stuff so that if you want to actually execute your own database, you can follow through. So keeping it, free tier, we're only using a regular DBT2 micro to just illustrate what we're doing. And with that storage, along with that, it's just a general solid state SSD GB2 storage type for that, and we're only allocating 20 gigabytes. So we can actually start off with a smaller number, originally at 20 gigs, but you can execute it all the way up, I believe, to 256, I believe, or even higher than that. But based on the allocated storage, we want to keep it down low so that we don't allocate more. And it really jumps up higher, higher than your AWS budget allocation can handle. So we don't want any surprises there. So storage auto scaling, we can enable storage auto scaling, but we want to turn that off because, again, based on any traffic and how you scale and set up your database, you don't want to scale up and scale down and create undue budgetary concerns for yourself. And because we don't have enabled any of those features, that's why we don't have multi-AZ deployment, which is creating that standby instance. And in the event that the main instance dies off, it moves and creates a standby instance. In the case of a fail. So with connectivity, I already created or rather used the default VPC to execute this database. If you want to create or associate in a database that you already set up, you have to make sure that your NACLs, security groups, subnetting, route table, you have to make sure your environment is fully connected, fully secured, and ready to make queries against that database. So moving forward, I chose my existing default VPC and security groups. And your availability zone. Make sure that wherever you are, make sure you associate that availability zone to what works best for you. Because if you choose something out of your availability zone or further away, it creates latency. Latency is time and possibly more money for you. So with database authentication, you want to use that. So once you log into your database, it will ask you and prompt you for your admin as well as your password credentials. And then you're going to create that database. Now, remember, I already created the database. I wanted to just illustrate it for you because it takes time to spin up that cluster. So we're going to move over into my RDS Management Console database that I've already created. So now I have my database demo. That's the name of the database that I've created. And so now you can take a look at what's going on with your CPU utilization. I really enjoy the dashboard and the ability to take a look at where your database is, what the CPU utilization has been, things of that nature. Oh, this is the wrong database. This is the one that I created for my database. So now, as you can see, it takes a while for this stuff to move. And sometimes you have to refresh your page a bit. So now this is the one that here we go. Sometimes AWS, it's very slow, and then it takes a while for it to catch up, which is why I didn't want to spin one up in real time. So now, again, this is my SQL engine, my database engine that I spun up again. We talk about CPU utilization, where we are, the class, the region in which I spun it up. And what I really love about it is that it provides all the connectivity information that you need to get an understanding of what's going on, what the name of the subnets are. It creates your one-stop shop of understanding what your database is doing, and it also provides monitoring. I really enjoy this dashboard because it creates an understanding of your CPU utilization, your database connections, free storage, everything. And you notice, like, when I have the freeable memory and you think about the writing IOPS, you can see how I spun it up, and you can see the throughput of what's going on here and the exercises that I've done with it prior to me setting it all up. So I really like the dashboard on what's going on and how you can get things going. So in the event you ever want to use, if you want to query against it, this is where you connect to your database. You have your database instance cluster. You choose that database. You choose all your associated database username, password, and enter the name of the database that you set up originally. I'm not going to go down this path. I just want to illustrate because this is where it gets into the developer piece of querying against your database based on the strings and everything else associated with it. So that's how you that's how you set up the database, the query database for yourself, specifically for SQL. It's just really instrumental in making sure that you keep your administrative, admin password and information available for yourself so that you won't forget it, because there's nothing worse than, like we discussed before, is locking yourself out of your own system. So ensure that you have your information and your database stuff available. So it's a very high level, very easy, quick setup for this database for you to be able to experiment with. And if you want to spend more time with Query Editor and adding on certain code, again, this is not what solution architects do, but if you want to play around with it and search it against yourself to get an idea of how things work, it's definitely, I definitely encourage experimenting and learning all that you can on the AWS database and everything within the environment itself. So I think if there's, like I said, very quick, very easy, high level, click, understanding what you're clicking, why you're clicking it, so that you can set up the database that is perfect for you. And also, you always want to give enough gigabytes in memory to kind of create more of a growth so that you can grow into it if you experience more traffic for your database. But you also want to just keep it low, experiment with that information, and just adjust as necessary so that you don't have extra budgetary concerns for that. So based on that information, that's about it. It's really quick. It's really easy to set up. And, as configurers, that's what developers and administrators, they focus on building it, configuring it, and maintaining it. But from a solutions architect's perspective, understanding what the concept is, why it is, when you would use it, those are the three questions you ask yourself, especially with the exam on how you can successfully answer those questions. So if there's anything else.
That's really key, is to know which is the skill for your job.
Yes.
As the architect like Alonzo and I, we start with the customer. We're asking that executive, what are their business goals? What are they trying to achieve? These are the things that we want to know.
Yes.
Now, we're gonna design it. That's our skill. That's our expertise. It's design. It's presentation. It's, doing the ROI modeling to show the customer the value of the solution is greater than the cost of the tech. That's what we do. The cloud engineers build it. After the cloud engineers build it, they turn it over to SysOps people to maintain them. Heck, some of the times we can just have a DevOps engineer and build it all as infrastructure and code. We design it and they build it. So the key is being really great on your job. Now remember, the AWS Certified Solution Architect Associate exam is a cloud engineering exam. It's related to the name of the service and how to configure it. It's completely unrelated to what we do as architects, which is design. We solve business problems with technology. So please kind of keep those things in mind. And that's why, when you get architects like me and Alonzo, we still know how to configure, because you still have to know how, but we don't do it. It's not part of our careers. Like, by comparison, a cloud engineer that's an expert at these things may not be able to convince the CEO to spend $1 billion on a technology solution, because that's not what they do. They would have no idea what the CEO needs to hear, what they care about. It's a completely different world. So train for the job you want. You'll be great at it. So prior to getting into security, and we know we all love security, let's give a round of applause for Alonzo. Even if it's virtually, Alonzo took time out of his busy day. He's a very busy, strongly in demand cloud architect to come and help for free, provide cloud computing training to all of you. So Alonzo, as always, you're a good friend, you're a great cloud architect, and I'm thrilled to have you as my friend and thrilled to have you help the world as well. So Alonzo, thank you.
You are more than welcome. I'm always happy to help you, Mike, at any time. Thank you.
Thanks so much, Alonzo. So now we're going to get back to some security things. And Alonzo's got a great security background as well. I love security. Heck, at 2 o'clock on a Saturday afternoon, we're discussing security sometimes. And every kind of security you can possibly imagine. People like Alonzo and I look at the physical security, we look at the application security, the human security. So thank you, Alonzo. So we're going to get into security. If you have a chance, you thanked Alonzo, great, please do so. Please smack that like button. Inform others if you're willing to basically participate. And let's begin with security. Security is near and dear to my heart. I've been working with advanced security things for decades now. And we're going to talk about a lot of things inside of this security section. We're going to talk about who's responsible for what in your organization. We'll talk about need to know, or principle of least privilege. We'll talk about industry compliance. We'll talk about identity and access management. We'll talk about multi-account strategies, most likely. Well, even though that's predominantly for the certified solution architect professional, I may or may not cover that based on time. We'll talk about network ACLs, security groups. We'll mention the AWS firewall called WAF. We'll talk about intrusion detection and prevention. We'll talk about distributed denial of services attacks. We'll talk about service catalogs. And heck, if you want, we can do a security whiteboard session when the time is right as well. So let's begin with who is responsible for what parts of things. So when you're dealing with a cloud provider, it's different than the data center. In the data center, this is really clear. You're responsible for everything. And because in the data center, you're responsible for everything, if you're really good, what you can do in the data center is amazing. So don't forget, AWS just has a bunch of data centers, which have really great servers, really great routers, really great switches, really great firewalls, and they're managing their own thing, and then they're reselling you their data center. So realize everything you can do in the cloud, you can do in the data center. But in the data center, you're responsible for all of it. Now, you can't do serverless in the data center. Well, actually, you could with it. That's neither here nor there, but we could talk about how to do that later with an OpenStack Ansible cloud. So when you're dealing with the cloud, you share the security responsibility. And I want you to think about it this way. AWS or Azure or Google, they maintain the security of their cloud, or at least they try. I mean, they maintain the security cloud, but realize they get hacked too. For example, Azure had a massive hack where they got access to everybody's database information very recently. All these cloud providers can get hacked because they're just like us. They're running a data center. But know that AWS maintains the security of the cloud, and you maintain the security of your virtual private cloud or your VPC. So AWS manages their infrastructure, which could potentially improve your security if they do a better job managing their infrastructure than you could of your own. So they manage the underlying tech and you manage the tech. Now remember, with security, you will always be more secure if you have equivalent security in the data center. Because when you're on the cloud, it's still a data center, but now you've got other people's stuff on it. And I want you to really think about security in a new way on the cloud. Everything you do in the data center and more on the cloud, because the cloud is inherently less secure. It's shared versus the data center is you're not. It's not just that. I want you to think in terms of an attacker mindset. I want you to think if you were a thug, if you were a warrior, if you wanted to have an impact, which would you hack? A data center or a cloud provider? If you attack the cloud provider, you get access to every customer they have, which in certain cases could be 20% of the whole internet. You attack a data center, you get access to the single data center. So if you're a smart hacker, where is all your time and effort going? The high value target, the cloud provider. So just by that nature, being on the cloud is riskier than the data center. Now, this does not mean I don't think the cloud is great, but we need to be honest about what we're designing. The cloud is not more secure. The cloud can be equally secure, but you need to work at it. So identical security requirements in the data center to the cloud, nothing less is acceptable. So look at it this way. You are responsible for the following things. Your users, like your IAM users, and their roles. Now guess what else? Patching the operating systems, maintaining the security of your apps, configuration of the AWS security options, the router that connects to the cloud. If I'm a hacker and I can physically plug into that, I can get on your cloud. So physical security of your devices. Does that physical security mean a locked door? Does that mean a physical security mean a locked door and a camera? Does that physical security mean a locked door, camera, and a guard? Does that physical security mean I need to hire an ex-Israeli commando or a Navy SEAL or a British SAS commando to guard the door with a camera? Security that you're going to add is going to be based upon what the assets are that you are protecting. I've worked with all of these situations in my career. So AWS calls it the shared responsibility model. That's actually a relatively good way to call it. Sometimes the branding of these organizations is a little funny, but the shared responsibility makes sense. Look at it this way. Basically, you've got AWS, and they're managing their servers, the physical servers, their hypervisors, their physical database servers. They're managing the network, most of it, and they're managing their storage, the physical storage. They manage their data centers, availability zones, edge locations, local zones, that kind of stuff. But you are responsible for your data, your firewalls, your operating systems, locking them down, your network ACLs, security groups, IDS, IPS systems, any kind of other things that you're using. So you are responsible for everything in your VPC. They are responsible for the underlying foundational technology. So one of the things to remember in security, and this is an important concept, is the principle of least privilege, otherwise known as need to know. What is need to know? You give the minimum level of access necessary for somebody to do their job. Minimum level, that's what you do. Use the minimum level as possible of access. Why minimum? If you give people more than they need to have, they will get access to better information. People talk, you'd be surprised the things that occur. If you have access to systems that you don't need and someone compromises your account, guess what? They can use it to hack. Do you know where a lot of the hacks accidentally really come from? We work so hard to build this firewall and IDS and network access control lists and security groups, all keeping us perimeter security. We do all of it. And we get hacked from the inside most of the time. So do not give people access to more information. Military, need to know. If you don't need to know it, you are not going to know it. When you're leadership, when you're an executive, one of these big tech companies, when you're a senior cloud architect, I promise you, enterprise architect, you will have access to tremendous information about the inner workings of a company, and you won't be able to share that information with anybody. So you will learn things that you will only be able to speak to in your inner circle, and you'll never be able to talk about it to the rest of the world. This is challenging. I promise you, it's super challenging. So military need to know, great way to do it. Don't give access. So give someone the least amount of access they need, and then lock them down. Don't let them get anything beyond that. So let's talk about and see what this really looks like. I've got a user who's an administrator. We're going to use identity and access management, a term which I absolutely hate. What is identity and access management? Who are you? Are you who you claim to be? Authentication. What are you allowed to do? Authorization, accounting. What have you done? If you don't know about IAM comes up a lot when the Certified Solution Architect Associate and Certified Solution Architect Professional exam. Chris, from my team, could you pop a link into the What is IAM video as well as the What is IAM blog to give as much possible help as we can to the cloud architect community that's sitting on this call. So here's how it works. Me, the user, I basically say, I want to access this thing. My username, password, what have you, is accepted, and I get access. Regular user tries to go to the management console. He enters his username and password or what have you. He is blocked. She is blocked because they don't need to know, and we are safe. Bob's your uncle. We are protected. So now you know a little bit about why we're using identity and access management. Now, one thing that you should note, and we'll talk more about identity and access management before in a minute. A lot of industries are very regulated. They have data retention requirements, must store data in an immutable vault for 7 years, meaning unmodified. Huge regulatory environment in healthcare, huge regulatory environment in payment cards, huge regulatory environment in banking, just literally speaking, huge regulatory environments for a lot of different places. So AWS supports most of these standards, as does Google, as does Azure. Otherwise, they wouldn't be able to work. So know those. You can get a full list of all the standards that are supported. I'll drop it into the chat box so you can get a full list, if I can even copy this into the chat box. But, I can't figure out how to do it, but okay. So don't worry about it. Realistically speaking, it's very important for you to just remember that whether it's PCI DSS, FedRAMP for the US government, HIPAA for US privacy, ISO 9001, 27001, 20017, 20018, most of these big cloud computing standards. AWS supports them all. So, just kind of understand that. Now we'll talk a little bit more about identity and access management. We'll work through a bunch of key concepts because AWS has their own terminology. IAM identifies who the user is, what they're allowed to do, and then tracks it. I used to call it AAA. We all called it AAA. It made sense to everybody. AAA was authentication, who are you? Authorization, what are you allowed to do? And accounting, what did you do? In fact, when you really talk to IAM architects, they don't use the term IAM at all. They all use authentication, authorization, accounting. Now, when you're dealing with AWS, they have a funny way in which they actually classify their names of IAM. Until we get into the complexities, for the most part, at the Certified Solution Architect professional level, at the AWS Certified Solution Architect associate level, we have IAM users, which are people like you and me. That is an IAM user. Now in AWS, we have an IAM role. What is an IAM role? For the rest of the world, we call it a service account. Like if you're in the Google Professional Cloud Architect exam, or if you're working for Red Hat, we have what's called a service account. A service account is an IAM role that's used by a server to connect to another server. So for your app server to connect to your database server, you have a service account. So AWS calls that an IAM role. So as a role at the associate level, this is going to change to the Certified Solution Architect professional level. A user is someone like you or me, and a role is a server accessing another server, often called a service account. And you might actually see a test question that would say something like, what is the equivalent of a service account in GCP? And that is an IAM role. So IAM role for a server to attach to another server, IAM user, human like us. Now there's variations of that, especially you get to the professional level across account roles and things which are different, federated identity roles, but at the Certified Solution Architect associate level, it's not really something they really talk about. That gets fairly complex. So I'm happy to do that at another time and go much deeper to IAM. If you guys want an IAM day, we'll have fun with it. Always happy to do things to go out there live and interact with you guys. I love doing it. So let's talk about what this really looks like. A user signs into the console, the management console, with their IAM account. That is authentication. Are you who you are? Now they'll provide their username, their password, a token, what have you, based upon our authentication type. Then the user tries to access something, and the user is either authorized, yes, you're allowed, or no, you are blocked, smack you on the wrist, you didn't do your job. So you're either authenticated or you're not. Authenticated means, yes, we know who you are, you're allowed, or blocked right then and there. Bad username and password, failed authentication. Authorization, Mike, you're allowed to work on this. Mike, you are not allowed to work on this. Accounting, Chris in the back end says, Mike made 1 million mistakes today. What mistakes did Mike make by filling out emails? And because Mike responded to 2,000 emails in one day and didn't have a chance to fully read the email, so you're a part of the email. That's not true. I'm very careful and meticulous, but Chris would be the person to catch me. And he would be tracking what I did to help me because I asked him to make sure I don't forget anything. So authentication, who are you? Authorization, what you can do. Accounting, what did you do? So now you know the roles again. So because we're talking about AWS and we want to get it right, let's talk about IAM users. So a user is a person just like us. We get permissions to interact with AWS resources. How do we get these permissions? They are created by a principal with administrative access. So we need an administrator to do this, to create the account. IAM users can be created on the management console quite easily, the CLI, or via the software development kit through the API. This is also important to remember. Users are permanent until you delete them. So if someone gets laid off or fired, You have to remove it. If someone quits and moves on to a new company, you must remove that user. It is absolutely critical for you to remove that user after you're done. Otherwise, they will still have access. So, this should be relatively straightforward for you, at least what we've talked about so far right now. In this particular environment, you can see what we've done. We've got a user, they log in, and they're allowed to access anything they need to. So EC2 instances, S3 buckets, databases, that kind of thing. So let's talk about some key IAM concepts. AWS made these terms up, they're not mine. The first time we have to talk about is a principal. A principal is an IAM entity that has the permission to access resources in the cloud. Okay, that can be the root user, an IAM user, or a specific role can do it. So principal is something that has the permission to access resources. Now let's talk about the root user. For those of you that are Linux users like me, Unix users like me, you're definitely familiar with the root account. The root account is the master account. When you first create an account, that is the root user. The root user can do anything. Delete your entire organization by accident. Set up $10 million a month, the monthly building by accident. Protect your root user account. Do not let this out of your sight. Don't use the root user for daily use. You wouldn't log into a Red Hat server as root every single day and use it as root. You don't do it in the cloud either. There's no way to restrict root access. So if on the root user, use some exceptionally strong passwords. Enable multi-factor authentication on your root account. And don't use this for programmatic access, like use another account. So don't set up your account for one system to access another system as the root user. Be smart. Remember that principal is privileges. Only give whatever is necessary to do the job. Try to remember that. How do I remember the root user? Well, it's not that hard for me because I've been working in the Linux, mostly the networking, but there's a lot of Linux and networking for decades. So I identify the root user as the king with the crown on the head or the queen with the crown on the head. They have unlimited privileges. They can do everything they want. The root user is royalty, nobility, whatever term you want to use. They're like the king and queen and prince and princess. They get everything they want. So don't log in as root unless you have no choice. Now let's go a little deeper here. Let's talk a little more about identity and access management. Since we know that IAM is used to determine who can access your systems, you could conceivably create a user and apply a policy to every user, and it would work perfectly. But I want you to think about this. How would you do that for Cisco at 80,000 employees? How would you do it for Apple with a few 100,000 employees? Would you manually, for hundreds of thousands of people, literally click each individual permission they could do? Well, you could. It doesn't seem to scale. Imagine cooking 100,000 custom recipes for 100,000 friends. Not a great idea. Well, if you do it, you could probably open a great restaurant, make tons of money, but not a great idea. So what do we do? We came up with the concepts of groups. What are groups? So let's say you've got a bunch of Navy SEALs. You create a group for Navy SEALs. Let's say you've got a bunch of Force Recon Marines, or MARSOC they're called now. You create a group for MARSOC Marines. Let's say you've got a bunch of Delta Force people from the Army. Let's say you've got a set of British SAS commandos. These groups that we're talking to have very good access to top secret information because they're the privileged, they're the few, they're the elite. So we might put a group that's called Special Operations Forces. Then we might have a group for the medical professionals that are working for the military. They don't often need top secret unless there's a virus or a bioweapon they would need to know. Then they would need top secret. So what you can do is you can have a specialty group and put all your users of a certain liking into that certain group, and then all the other users in another group. And you can just apply policies to the group. So think about it. Systems administrators need the most access. Sales reps don't need a lot. Give Come up with a policy for the systems administrators giving access to everything they need. Create something else for the sales reps that need very little. Create something else for HR that only needs access to what they need. Create something else for the finance team. Basically do it this way. Create a bunch of groups, add policies to the groups, and then when you hire a new cloud architect, put them in the cloud architect group. When you hire a new sysadmin, put them in the systems administrator group. Put people in the group, apply the policy to the group. Now you've got a company like Cisco, and maybe you have 500 different roles that people do instead of 100,000 different things. Big difference, 500 versus 100,000. Groups are a way to group users. Maybe put your finance people in one group, security people in another group, sysadmin in another group, and give each group the privilege they need. Imagine 2, 3, 400,000 users trying to configure a policy that is personalized for each one of them. To me, that sounds like an absolute nightmare. That's why they came up with the concepts of users and groups. These are not new concepts. We've been using it for 20, 30 years with Microsoft and other places. So not new. New versions of the same thing. Kind of like the song, Meet the New Boss, same as the old boss. Same kind of concept. Let's make it fun. Let's learn. Users are people. Groups are groups of people. So how's this thing going to work? You create a group. Very simple. You provide the permissions to the group, and you just add the users to the group. Now, we're going to get into some more complicated IAM things, and I've been debating about it. Do you guys want me to give you just what you need to know for the Certified Solution Architect Professional, or do you guys want more? Do you guys really want to know the IAM piece that's going to help you get hired, help you with the Certified Solution Architect Professional exam? If you want me to stop right here, this is what you need to know for the Certified Solution Architect Associate, I'll stop here. If you want more, let me know right now in the window. Full IAM or abbreviated Certified Solution Architect Associate IAM. Let me know, and I'll give you whatever you guys want. While you're at it, Chris will tally up the results. Smack that like button. If you're not a member, please subscribe to the channel, and then we'll take it from there. I'm looking for some responses from you guys so we can deliver you the best experience in the entire world.
Mike, I'm not going to tally anything. There's no tallying.
Okay, even better. More. You guys are awesome. I love working with you guys. Here's why I love working with you guys. A certification junkie says, tell me what I need to pass the test. An architect says, tell me what I need to do the job. You want more? We'll do more. Super happy that you guys are here after day 4 looking for more. J. Jim Wentworth, 877 Cash Now. Love that, Abigail. More. I love it. We're going to do more. So you guys are awesome. We love you all. From Jesse, more. Okay, we're going to do it. Is my friend in Greece hopefully here along the way? If so, maybe we'll do it in Greek. Nope, sorry, I guess we have to do it in English, but I still think it would be fun. Okay, so let's do a little bit more. Let's talk about roles and tokens. So let's do it. When we're talking about roles, as I mentioned, we're talking in general at the Certified Solution Architect Associate level of systems. So now we're raising our level. We're becoming more cloud architect work. We're going heavier, higher up. So while we're doing more, let's do more. So let's talk. We talked about the service roles. That is an IAM role that is associated from one user connecting to, or for a server to connect to another one. But there's 2 kinds of roles. There's something called a cross-account role, and there's something called an identity federation. So we'll probably get to there too. So IAM roles enhance security by basically making sure that you have the ability to connect to external partners, to deal with external identity providers. So what's going on is AWS uses an API. And when you're using this API, what's going to go on is as follows. Normally speaking, you enter a username and password. But what's going on here with these roles is basically they have some kind of credential. They hit the API. They are actually then given a temporary token, and the temporary token is actually sent to the receiving end. And what happens, these tokens are constantly being rotated. And because the tokens are being rotated, they're constantly new. There's no passwords. You've got a token that's good for the next hour, and then a new token for the next hour. So even if a hacker were able to get access to your token, they only have access for a very short period of time. So what we do here is as follows. We generate a token and we rotate the token. So when you're dealing with these IAM roles, and there's a lot of them, which we're going to talk about, it's based upon tokens. So one-time passwords, tokens, token vending machines, there's a lot of it. The point is, if it's your password, that's your cat's first name, and I would never do that. My cat's name is Cindy, and I have no passwords named Cindy. But if someone guessed the password Cindy to my sweet, beautiful, loving, adorable cat, and Chris, of course, you can put a picture of my cat if you want on the window. Mike loves his cat. My cat's like the queen of the household. Although yesterday we had to climb a large ladder. She got herself 50 feet in a tree, or 30 feet, whatever it was high. And we had to try and get the kitten out, because how she climbed that tree, I have no idea. But she gave me, her father, a near heart attack. But that's neither here nor there. So roles enhance security by using temporary passwords. As I mentioned, yeah, that's my cat Cindy. When it was raining outside, she was not very happy. So when we're dealing with roles, they're used by systems. So let's talk about the AWS, isn't she cute, everybody? Security token service. It generates tokens, and the tokens expire. Boy, she really is a beautiful cat. And the tokens expire every 60 minutes. Now you can set the token expiration to 15 minutes for a super high security environment, and you can set the token expiration for 36 hours if you wanted it to stay there. So just keep track of those kind of things. Yeah, Cindy's really growing up. She's like tripled in size. And thank you all for your kind words about my beautiful, beautiful best friend, Cindy the cat. I bought a cat for my wife. I wasn't even a cat. I bought a cat to surprise my wife. She came home, jumped in my lap. I knew she was coming home with me. She hasn't left my lap, and she slept in between my feet or knees, literally speaking, since I bought her. I thought I was rescuing her. She's made me so much happier. I think she's that rescue cat rescued me. So anyway, slightly off topic, but we might as well have fun here. I love my cat. So let's talk about these IAM roles. They're typically used for granting permissions to an EC2 instance to connect to something else, but not always. If you connect to another VPC, you have something called an IAM role. Yesterday, she was in my lap all day. Today, she's actually outside doing things like finding little things. Hopefully, she comes back really soon. So it's an IAM role. But if you do VPC peering and you want to access content into somebody else's VPC, that is also called a cross-account role. So a cross-account role is a role that gets you into somebody else. Now, when a user traditionally accesses a system, they're called a user. But when the user applies to accesses information in somebody else's data center, that's called or other VPC or cloud, that's called a cross-account role. And we're going to talk a little bit more about those cross-account roles. How does all this stuff work? There's the AWS Security Token Service. What happens is it generates these tokens that expire, as I previously mentioned, and these are temporary credential generated every time you request them, which I absolutely like. So let's talk about the cross-account role. They enable you to access another account. So it's often set up for one user to access things in another account, but it can also be set up to access, realistically speaking, so if I'm Go Cloud Careers VPC and Alonzo has Alonzo the Cloud Architect VPC, and I want to connect my VPC to Alonzo's, we're going to do some VPC pairing or private link like we talked about yesterday. Now, when Alonzo, who I know, respect, is a good friend and I trust, wants to access my stuff, he's using a cross-account role. When I want to access things in Alonzo's environment, I'm going to use a cross-account role. So these are set up where you can access accounts that you don't know. Now let's talk about some best practices, because this is dangerous. It's not dangerous for Alonzo to interact with my VPC because I know him. But when you're connecting with other organizations, it's dangerous. You're now having a user that has authorized access to your systems. This is scary stuff, everyone. It's kind of like giving somebody keys to the house, your own house. If you've got a lot of cross-account roles, these are other people with keys to your house. Do you give them just keys to the house? Do you give them keys to your safe plus the house? Do you give them keys to your bedroom plus the house? This is up to you. That is what that authorization is. These are the things on the cross-account roles. So cross-account roles connect you to other entities. So when you connect to another entity, a partner organization, think about the business opportunities, many and multiple. The partner company may need to access yours. And if you give a partner access to things, what do you think you give them access to? What they need to know. It goes back to need to know, principles of least privilege. If Alonzo only needs to access Mike's cloud network and security designs for the last 3 decades, I'm only going to give him access to that. But if Alonzo needs more, I'll give him access to everything he needs. Same concept, principle of least privilege. Give people access to the minimum necessary. So while we're talking about cross-account roles, and admittedly, this is dry stuff, so thanks for being willing to pop up with more. I just wanted to give you more. But so the cross-account roles are there. So you set it up as one user. And when you're setting it up, here are the things you need to know. You set it up to allow access to the accounts you don't know. So you're connecting an external account to you. So what do you need? Well, you need to know the account that's connecting to you for one thing. So that's called your external ID. And an external ID is going to be a secret identifier known by you and the third party. In this case, Alonzo and I are sharing experiences and sharing lessons, and our VPCs are connected, and we each have cross-account roles to each other's environments. And we've set up the appropriate permissions. So let's look at it this way. So basically speaking, in this environment, you've got 3 companies that you're providing access. So the cross-account role is just using IAM to determine what company A, company B, and company C can actually access inside of my VPC. That's it. That's all it really is. But they just make up such complex terms. How do these roles work? You create a role for the user. So a role is created for the external user. So Alonzo requests access to Mike's network designs. As soon as he connects, what's going to happen is he's going to get a temporary token from the AWS token service, the STS, AWS Secure Token Service. He gets a temporary token. Then Alonzo provides a temporary token. My systems evaluate Alonzo's temporary token, and it says, ding, 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 winner, winner, winner. Alonzo, welcome, you are allowed in. So that's how these cross-account roles work. Now remember, a role is taken, typically speaking, we've got service roles for EC2 instances that are typically used for, say, a server to maybe access an SQSQ, an EC2 instance to an S3 bucket, and relate an EC2 instance to a database. These are service roles. These are things like service accounts on Google or service accounts in Linux. That's all these roles are. This computer wants to access this service, it's given a role. So that's kind of all these things that are going on. So now let's talk about identity federations. This is pretty important. So let's look as follows. Do you really think that you're going to go to the AWS Management Console and create users and groups for a 200,000 person company? No. So when we start talking about a lot of these IAM features and functions, I think it's pretty important to actually understand what you're actually going to do with the AWS IAM service is going to be really limited. And the reason it's going to be really limited is you're not going to go to some management console every single day, add users and groups. It just doesn't scale. So organizations have IAM applications. And this is where we're going to get involved in identity federation. So we talked about the IAM users and roles Great for passing the AWS Certified Solution Architect 2022 exam, for example. But in real life, you're probably going to be doing some federations or some integrations between scalable identity components. So let's look at it this way. Let's start with a federation. A federation is basically you take the AWS identity environment and you connect it to something that does identity. And then the AWS environment inherits by communication. Realistically speaking, it inherits all the identities from the identity store. So let's say Active Directory. Everybody uses Active Directory to authenticate users, to authorize users, and to figure out what they have done. Active Directory is a little weak on the accounting side, so there's other tools that people use in the industry, but everybody uses Microsoft Active Directory for their IAM. So what'll happen is in an identity federation, you will take your AWS environment and you will connect it to Microsoft Active Directory, and it would pull all the IAM information, and basically you can sign into the Active Directory, and then it will give you access to the rest of your AWS services. That's called single sign-in. So the way this identity federation is going to work is basically you're going to have an identity, which is a user. You're going to have an identity store, which is where your users' identities are stored. Think Microsoft Active Directory, or connecting to Facebook, or connecting to Amazon, or connecting to Apple as an identity provider. And then you're going to have an identity broker, which is going to be an application that checks the identity store and provides temporary access to AWS. So think about it this way. Identity is a user. Alonzo is an identity. Alonzo and a few friends are setting up a Microsoft AD server for me because I don't have time to do it myself. They're going to do it because our cloud architect career development program has grown so much. We have so many users coming in and they're all super successful. So the point is, when they come in, he's going to put it into a Microsoft Active Directory server, which is automatically going to provision my users' VPNs into the data center, give them accounts on all our VMware servers so my students can build a cloud with less intervention. I've done it basically the AWS way the whole time. I've put it into Cisco and I've put it into other components of our data center, but it's not scaling, so I need to have Active Directory. So I reached out to my good buddy, Alonzo Coleman, a fantastic cloud architect who's done lots of Active Directory work in his career, and he's building me an Active Directory server. So I'm a user, the identity store is the Active Directory server, and the identity broker is going to be that in-between intermediary. So when a user logs in, they get sent to Active Directory, and then this identity broker comes back and it tells AWS, yes, Alonzo's welcome into Mike's data center. He's doing a project. He's building Mike an Active Directory server. So now you guys should understand. So how does this work? Now I'm going to give you the ugly technical nitty-gritty. So bear with me. These are going to be AWS terms and more closely related to AWS words than mine. So the first thing that's going to happen is the user is going to log into the identity broker using their corporate credentials. Then the identity provider will authenticate against the LDAP-based identity store. Think Active Directory. So then the identity provider will generate what's called a SAML assertion, which is security assertion markup language. It's the language used to connect to identity providers. And it will submit that information to the identity broker. The identity broker is going to call the assume role with SAML, AWS STS token service to get a token, and it will pass that SAML assertion to the role, so Amazon Resource Locator name, and it'll assume it. If the API response is successful, it'll give an AWS temporary security credential to the people with the associated permissions. And then, with the temporary credentials, the client application can perform the operations on AWS. Like I said, this is more an AWS terminology. I like to communicate plainly, but this is their terminology. If you're on that certified solution architect professional, you must understand it in their words. So we've given it to you in words that are more closer to them, less industry terms, more AWS terms, because this is an important concept on an AWS test. Here's the thing. Remember it this way. You got a system. You're using SAML 2.0. It's basically a language to connect to external providers. You connect that to Active Directory. User logs in. It hits the database. They get a token. They log in. It's not that complicated, but you're basically integrating Active Directory or Facebook or Twitter or LinkedIn or any identity provider and pulling their information and using it to authenticate your users in your environment. So let's really think about this one more time. We're using one of two connection languages. We basically have two ways to connect to identity providers. It's SAML 2.0, or a security assertion markup language, or something called OpenID Connect, OIDC. I want you to really think about this in your life and experience. Have you ever logged into a service and it says, log in with Google, log in with Facebook, log in with Apple, log in with this, or create a username and password? This is what's going on. This is exactly what's going on. So no different. Now let's briefly address single sign-on. Single sign-on is as follows. It's an authentication method that enables your users to securely authenticate with multiple applications or website with just a single set of credentials. So instead of logging on to 10 times, log on once and be just pass through in. The AWS has a single sign-on service that enables a user to sign into one place and access resources and a whole bunch of other AWS services in your account. Single sign-on is usually used in a federated environment. Connect to Azure, Active Directory, Microsoft Active Directory, Salesforce.com, some kind of a database that's going to have this. Single sign-on is going to enable your user to authenticate once to the identity provider and then not sign in again. So it's a real convenience factor. Really improves user experience. When the user signs on, they get authenticated against the identity provider, their groups are determined, and their privileges are assigned. So single sign-on is really nice and elegant. Here's what happens. Basically, you take your Active Directory server, you federate that with the AWS single sign-on service, and then you sign on once and you can access anything you need. Okay, wow. So let's do a little bit more on Cognito, and then I think we probably need to get back to some more of the content that's associated with this curriculum, but I really want to give you more. So AWS has this concept of Cognito. So there's this concept of AWS federations, and there's a service called Cognito. And Cognito is a service that's going to provide authentication, authorization, and user management of web and mobile apps. It's going to provide an ability to connect to identity providers. It's going to enable organizations to synchronize identity management and data management across mobile devices. Cognito users are going to be able to sign in directly with a username and password or with a third-party identity provider like Facebook or Google. The way it works, it goes back to the same concepts. We've got a user or app that authenticates against Cognito and gets a token. So let's show you a little bit more about this. And I am not Mr. IAM, but I've been working with a lot of IAM over the last 2.5 decades. But I'm not Mr. IAM. I've spent most of my life in enterprise architecture, cloud architecture, and network architecture, or leadership skills. But still important to know. Here's what happens. The user authenticates and gets a token. They then trade that token for credentials, and then they use that token, the credentials, to access their AWS services. Okay, bear with me. I'm looking at some more of this IAM, trying to figure out exactly how much we have to cover. So we'll go a little more, and we'll talk a little bit about identity federations. We talked about Cognito and it uses the concept of user pools and identity pools. See, here's what we actually do. We secure a directory within Cognito, and that's going to enable you to manage your users in one place. And a user is going to authenticate to a Cognito and get a temporary set of tokens. And what kind of tokens do you think they're going to get? They're going to be a JSON web token. Why JSON web token? This JSON and JavaScript object notation is used all over for all these IAM things. So we'll do a little more. In this concept, we'll talk about Cognito identity pools, and that's going to provide the temporary AWS credentials. Identity pools will work with authenticated, but also unauthenticated identities, and Cognito can work with guests, both authenticated and unauthenticated, provided they have a function. Now you know a little bit about Cognito. I'll tell you, I'm going to give you now the deep AWS message. A user will log into their identity provider. This is how it works. Step 2, after authentication, the identity provider will return a session key for the user. 3, using the session key, the application will issue a call to the Amazon Cognito Get ID API and get an identifier to the user. Then Cognito will validate the session key from the login provider. And if the session key that it receives is valid from the Get ID API, what will ultimately happen is a unique identifier will be returned for the user. Then the user will send their unique key to Cognito, and Cognito will validate the session key against the identity provider. And if the key is valid, Cognito will give the secure token. They use the AWS secure token service to generate a token, and the token will be provided so users can access the AWS resources. Let's talk about let's talk about authentication. We're going to have 3 basic options in the cloud, and I want you to know these 3. Here's the basic one: username and password. So user logs into the console, and AWS verifies the identity that's been given, and it provides an authorization based upon the IAM user's privilege level. After this, that's a username and password. A user can use an access key to log in, which is much better. An access key is a 20-character key ID, as well as a 40-character secret set. The access key is used to connect to AWS via the API. This is typically used with the software development kit. Now, if you want to get even more secure with regards to logging in, what you're talking about is an access key and a session token. So you've got the 20-character key ID and the 40-character secret and a token. So now rotating things, varying keys, huge length. Now you're talking about some authentication access. And we're talking about, realistically speaking, a whole lot. So remember this: authentication, who are you? Authorization, what are you allowed to do? And then accounting, what have you done? Now let's just talk about the last part in this section. How do you create your IAM policies? Well, if you're an architect, you're not going to be doing it anyway because it's going to be done by a cloud engineer. But how should the cloud engineer be creating these IAM policies that's going to be configuring them? Well, there's 2 kinds of ways you can do it. You can use a customer managed policy or an AWS managed policy. So what's going on is you can create an IAM policy, and it's going to be in JSON notification, and you can provide access to specific resources based upon the Amazon resource name, or ARN, or you can use the wildcards. From those of you that are familiar with regular expressions, they've got wildcards like the asterisk, which means allow everything. So you're going to create a policy. This policy is basically going to be either an AWS managed policy or a customer managed policy. Let's talk about the advantages and disadvantages of each. When you're dealing with an AWS managed policy, it's going to be a standalone policy by AWS. AWS made these policies, AWS knows their systems, and AWS has made them in a simple manner for you. They've got policies for pretty much everything, and they're well-architected security policies, and they're well-designed. And in most cases, you can select something right from here, and it's going to meet your need. Optimized for common use cases. And it can be based upon job role, level of access. AWS does a really great job here. There are two major predefined profiles. One is administrator access. Hey, you can do anything, kind of like the king or queen, prince or princess, or my cat Cindy. She has access to everything. Off topic, but she gets cooked shrimp once a day and fresh tuna once a day and scallops once a day. She's got a rough life, let me tell you. But the point is administrator access is like my cat, like the queen, like the king, can do anything. Now, power user access is basically you can do everything else except identity and access management and something called AWS organizations. We won't cover AWS organizations here because that is not addressed in the Certified Solution Architect Associate, and that stuff gets pretty ugly to talk about. But if you want, we can make a YouTube video on organizations someday soon and really explain that concept for you. So administrators can do anything like Cindy the cat because she's the princess, and everybody else is the power users can do everything other than IAM. Now, of course, you can make your own policy. So if you're an expert in writing, what do you call it? Identity and access management policies, you can write your own. So that's a policy. Definitely an opportunity for you should you desire that. Or you can take a policy from AWS and use it. I recommend using an AWS policy. If you can't use an AWS policy, make a custom policy by doing the following. Take a pre-made AWS policy, adjust it for your needs, but stick with the AWS one. So that is my recommendation. So here's what we're going to do and how we're going to do it. You can go to the console and in the navigation page, choose policies and just use them. That's the way I would be using it for the majority of things. The alternative is a customer managed policy. You make it yourself, which means you have to know how to make the policy. I recommend copying an AWS managed policy and edit. You can also use the policy generator. I'll show you what that looks like in a minute. It's kind of a questionnaire, and you fill out the questionnaire, and a policy is written in JavaScript object notation for you, and you can just use that policy. Or if you're a great JSON programmer, and you can just create one from scratch. But realize this, if you mess up on this policy that you're making from scratch, you've got a security nightmare. So I strongly don't recommend doing that unless you are an expert programmer. Here is the policy generator. It's basically a page you go to. On this page, it asks you some questions, for example, and you fill in the questions and it spits ones out. For those of you that have not seen an IAM policy, it looks like this. It's going to have a version statement. It's going to have effect of allow or deny, and it's going to be associated with a certain thing, like the ability to attach or detach a drive to an EC2 instance. It's going to specify the resource location, and the condition specifies optional elements. I am not a JSON programmer. I am an architect, but you still need to know the basis of what's in these things, even if you're not need to know what's in these things. So let's talk about applying that policy. You create the policy, you create users for a user, but remember we have a scalability problem. We create a managed policy, which you can apply to groups, like create a policy for finance or policy for developers or finance production or a policy for testing, or we can basically just add users to groups, and it could be a basic, simple policy. These are the kind of basic, simple policies that we're referring about. This is, you've got a group of administrators, they need lots of access. You've got a group of developers, they need moderate access. You've got a group of testers, they need access to a lot. So you have different policies for different sets of people. Last thing I want to talk about in the IAM section is multi-factor authentication. Multi-factor authentication is really, really important because it can substantially increase your security. Look at it this way. I don't use Cindy in any password, but if everybody knows I love Cindy, they would say Mike might use Cindy as a password. So you can take what's called a dictionary attack or a brute force attack and try a whole bunch of random passwords. And no, I don't use Cindy in anything, but people would try using Cindy. They would try Cindy 1, 2, 3, 4, and they would try variations of Cindy, and they would realize it wouldn't work because I don't use Cindy as a password because it's too guessable, because I was a security architect for a while. But if I used Cindy as a password, which would be dumb, but let's pretend I use Cindy as a password, and you guess Cindy's password. You have access to the system. Let's say you guess Cindy's password and you tried to delete my VPC. Now, I don't use just passwords. I recommend multi-factor authentication. Multi-factor authentication typically involves something you have or something you know, kind of like an ATM card. You've got a card, but you need a PIN number. That's something you have, something you know. Multi-factor authentication could be something you have, and something you know, and something you are. It could combine a password with an iris scan, or a fingerprint scan, or a face scan. That's multi-factor identification. It can work with an RSA secure ID that changes constantly. It can use with a Google authentication device. If you've not had any experience with Google Authenticator, I recommend you get some experience. Go download that, go find the seed key. It's completely free. Watch how it generates new passwords every few seconds. If you've never done it, it's completely free. Google Authenticator, practice it, play with it if you're not used to it. The way multi-factor authentication works is as follows. In multi-factor authentication, you've got a user that's going to basically sign in. This user signs into their account. Maybe they provide a username and password. Maybe the user is then sent a challenge looking for a one-time password, and then the user provides the one-time password and is granted access. Huge, huge, huge improvement over just username and password. Look at it this way. Somebody guesses your password, sends a message to your phone. Lots of types of multi-factor authentication, and realistically, it's that. So let's do this. It's 3 o'clock, but I know people have questions, so let's answer the questions. But before we answer the questions, if you've been having fun, if you can type #CloudHired in the group while Chris is pulling up questions. If you have not, hit the like button, subscribe to the channel, please do so, hit the bell, and inform others so we can expand our mission of training. As all of you know, our mission at Go Cloud Architects is to get you cloud hired. We are not in the certification business at all. We're completely doing the certification training because we've gathered and looked at everybody else's certification training, and we couldn't find anything that could help you get cloud hired. We know that a really good certification training, a real boot camp where you can ask questions, gets expensive and is out of the budget of many people. So we're here for you. So that's why we're doing this. So now while people are typing cloud hired, they're hitting the like button, which makes us happy. Chris, if you can bring up the first question, I'd love to answer it. Is a cross-account role doing federation SSO? Well, it could be, and if you connect to a federation, it is kind of a cross-account role. The answer is yes, but you can do a cross-account role, like basically, let's say Alonzo and I want to take our environments and connect them to each other. Alonzo wants me to give permissions. He wants to give me permissions to look at his network designs, and I want Alonzo to look at the IAM components of my designs so we can access each other's systems and share information. So in a way, yes, but in a way, no. So Doreen, I hope I answered your question there. Kenny Zhang, do I practice regular password changes for service accounts? Well, regular password changes are a must, but a lot of the service accounts use that security token service, so they're automatically using one-time passwords that rotate constantly, Kenny. So it doesn't become as much of a problem because the cross-account role, the service accounts are using the token service. Lenny, is this federated similar to an OAuth 2 authentication? In a lot of ways, the answer is yes. Paulos Million, will we make a certified developers course? Probably not. We are definitely under no circumstances in the certification business at all. Certification will help you get an interview, but certification does not get someone hired. We are not in the certification business. We are in the career development business, to building careers, and developers courses is not something that we're trying to do. We do courses to help people get hired. Getting them hired is very different than getting them certified. I am not a developer. I'm an architect. And we are unlike the certification providers. We do not make courses for which we don't have decades of experience. You won't see me take a developer's course, get a certification, and teach it tomorrow because it would not be fair to you. I am not a developer. And because I am not a developer, it would not be appropriate to make a development course just because I could easily pass an exam. So we're not there. We also typically don't focus on development careers for the following reasons. We look really hard for the careers that give our students the best possible career opportunities. How do we determine what gives our students the best possible career opportunities? We do the following. One, we speak constantly to recruiters and hiring managers. And when I mean constantly, I mean every day. We're obsessed with speaking to hiring managers and recruiters so we know exactly what we want. When we look at industry trends, when we look at the supply and demand curves, when we look at salaries of IT professionals, we find certain careers that are really blossoming. We're talking about cloud architects, we're talking about cloud engineers, we're talking about DevOps engineers, we're talking about cloud network architects, we're talking about network architects and security professionals, as well as data science. They are in our top 10. We try to stay out of development careers. We don't like to do development careers for the following reason. Many people in college are taught how to code. So there's a vast abundance and surplus of people that can do coding. When you have a large supply, you have low pricing, which means the developer salaries are substantially lower than these other careers. We love developers. Developers are needed, but we focus on these top 10 careers. We focus on the careers with the highest salary. We focus on the careers with the highest promotability. So when we're talking about this, we're really looking to how do we give you an advantage to earn double or triple your competition in technology? And because of that, we look at the supply and demand curve. We look where the industry is going. We look where the hiring managers tell us. We ask the executives in these companies, what do you need most? And they always say cloud architects, network architects, security architects, cloud security architects, DevOps engineers, and people that know what to do things with data. So these are the careers that we recommend. We work on building the people the best and most elite careers in the business. So we typically stay out of that. But again, I'm not a software developer. And unless I can hire a software developer with 20 plus years experience, we don't do it. When we make a course, like for example, I'm not a DevOps engineer, but I think DevOps is so great. We're making a course with Sandeep Das. We'll do what I do great. Teach people how to interview, teach people how to get hired, teach people how to be what the hiring manager wants, get them promotable, get them there, all the things that we do, how to negotiate higher salaries. And we'll have Sandeep do what he does, how to become a DevOps engineer. It is not fair to you to produce a course for which we don't have at least 20 to 50 years of experience in the course we develop. The cloud networking career course, for example, has 3 CCIEs with a combination of 50 years experience, 20 plus years working at Cisco, and almost a decade working at Juniper Networks and every other thing. So that's our approach. We only teach where we know we can be the best in the world at. So next question. What's my advice on taking remote jobs? Remote jobs are awesome, Ben. I've been working remote since 2000. I haven't commuted to enough.
Two.
Oh, well, it depends if you're able to juggle it. 2 remote jobs, 2 girlfriends, 2 wives, 2 boyfriends. I don't know, kind of sounds kind of complicated to me. But, you know, I worked 2 full-time jobs while I went to the university. It can be done. If they're 2 part-time jobs, fantastic. But, you know, it reminds me of this TV show, Three's Company. There was this guy, one of the characters was Jack Tripper. He'd always be accidentally scheduling 2 dates on the same day because he was forgetful. They'd both be in the same restaurant and he was running it out of the bathrooms and changing his shirt, not to be seen. That's what it's like having 2 jobs. I did have 2 jobs at one point when I was transitioning companies. And let me tell you, it was really a nightmare. So if you need to do it, do it. If they're 2 part-time jobs, great. But imagine what it would be like having 2 wives or 2 boyfriends and 2 girlfriends.
Let's remember the privilege. What's the principle of least privilege? Let's just do what we need to do and keep it simple.
Doreen's got a great question. Do I recommend the AWS security certification? No. Here's why. These are the certifications I recommend from AWS. The Certified Solution Architects Associate and the Certified Solution Architect Professional for people that desire architecture or engineering. For people that want to do DevOps, I love the the DevOps Professional. The AWS Advanced Networking course, I want to let you know what it is. It's an intro to an intro to an intro to junior level networking. The AWS Advanced Security is an intro to 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 junior level security. You want to be a cloud security architect, you get a CISSP, and you marry that with the Certified Solution Architect Professional. You get a CEH Master, you marry that with the Certified Solution Architect Professional. You get a big industrial certification that, like this, that shows that you really know it. You marry that with a great cloud certification, and you've got it. Here's the reason I strongly don't recommend against these cloud certifications. The AWS certification providers are really good at getting you certified and knowing absolutely zero about your career. I've interviewed 1,000 AWS certified people before I decided to launch this program. They all knew the name of the service and how to configure it, but not a single one of them knew network design. So I don't recommend these AWS certifications other than the Certified Solution Architect Associate and Professional and the DevOps Pro, not for architects, but for DevOps professionals. Because these courses are so good at teaching you how to pass the exam and know nothing, hiring managers like me look at them and say, I want that CISSP, and I want that CEH, and I want that CEH, and I want the Certified Solution Architect Professional. Get the big ones. Don't get a bunch of associate certifications. Get the biggest ones in your field, and you'll always have advice. Judith, thank you so much. Shalendra, what is the scope in cloud penetration testing? For the cloud security penetration testers, they have the identical job to penetration testing they do traditionally. Nothing changes. The cloud changes nothing. A developer off the cloud is a developer in the cloud. A network architect off the cloud is a network architect on the cloud. We do the same things in every way, shape, or form. The cloud's just a data center that's been virtualized. So cloud penetration testing is the same, but you may find out it's a lot easier to hack the cloud than it is the data center. So you have to, what you'll find out is because the cloud is so easily hackable, you're going to be using a lot more marketplace solutions. Next question, Chris. Unless there's none. I can't hear the other folks. I'm not sure if they're there.
Yeah, you ran them off with that, or you soaked them up with that hour worth of security. So. Are you talking to me?
Well, I love security, and I've been working in it forever. If you're not secure, you're hacked. If you're hacked, you're down. If you're down, you're out. So security is the key. People have contracted me for 20 plus years to build them 5 nines available network. And you know what? If you need to be 99.999% available, which means 5 minutes and 15 seconds or less of downtime per year, you got to be pretty good and secure. So security matters.
So what are we going to be covering tomorrow?
What are we going to be covering tomorrow? That is a absolutely fantastic and fun question. We will cover firewalls. And after firewalls, we'll talk about DDoS. Then we'll talk about some of these AWS security services, the kind they cover in the penetration, like GuardDuty and Shield and Inspector. And then after that, we're going to start getting into the AWS applications and services, of which we've got a lot to cover, like a lot, and a lot some more. But we're going to do out there, and we're going to do everything we can. We will try to finish tomorrow. As you can tell, we ran this as a real class. We let you guys ask questions. When you guys desired more, guess what? We'll give you more. Like I said, next month, we're going to do a free Cisco Certified Network Associate Bootcamp. At least that's in the plans, provided we have the time. Networking is absolutely critical for the cloud architect. Mag always has the nicest things to say. Thank you, Michael, Chris, Alonzo, and Jesse. Has been such a positive week. Thank you, Mag. Evo, God, I got to tell you, the messages you provide are always the sweetest things. Doreen, we're more than happy to actually help. Here's a great question from Dope Rated Visuals. Every one of the previous day's sessions is here. and you can access the first 4 days today, or the first 3 days. Today is the fourth day. We're going to go running on. I will bring Cindy on live. Actually, yesterday, Cindy was actually sitting on my lap the entire time. She was sitting here. I was like, how's my beautiful cat? How's my beautiful cat? You know, she is just the sweetest and most loving thing. So I will definitely bring her on, Daniel, one of these days. We're 99.9. If your 5.9's happy, Evo,
Yeah.
I love it. I also
We'll
love
take
the
that.
European comma, and instead of the period. I'm used to using it myself. Tomorrow we'll start exactly at noon Eastern time, which is 5 p.m. UK time. We will never, Killian, we will never forget Cameroonian folks. We have over 50 wonderful Cameroonian students. We've got over 80 wonderful Nigerian students. I can't tell you how many wonderful students we have in India, the US, Canada, Central and South America. You name it. We're in each and every one of these places, and we love doing it. We will never forget about you. So you didn't even have to bring it up. But since you brought it up, we'll never forget about our Cameroonian friends ever.
Can we have everyone put where they're enjoying the boot camp at, like we did yesterday? Where's everyone from?
Yeah, please, if you could let us know, because we love to know where you're from. I know we cover a lot of the world, and we do a lot of this free training to help those in developing nations. We will finish Kazi. We will finish either on tomorrow or on Sunday, based upon how long it actually takes us to get through. Okay, Judith, I see, is from the Cameroon. Dare Lassie. Dare is a common Nigerian name. So I'm sure you're Nigerian in Scotland.
There he is.
Leo is one of my students. She's great in Brazil. Eva, as I call her that, is Bulgarian, but I know she's living there. SM7 from Kenya, fantastic, living in Raleigh. I think you just became my student. Delroy is over in New York. I know that. Sanchez Singh is in India. Dan's in Chicago. Diaz is in Mexico. Abigail Marks, Axel, North Carolina. I've got a friend that moved there. Uruguay, I love that. Nigeria, I love that. Cameroonian living in Minnesota.
If I could, I would get a plane ticket and go to every particular city in country. Would love to do so.
I would love to too. We have another from Nigeria. Jeannie's in the US, but she's from Ethiopia and was kind enough to send me Ethiopian spices, which I have yet to cook properly. I keep trying to make kiftu and durwat, and it's not coming out the way I want it to. So any guidance would be there. But my Ethiopian spiced lentils have come out great. Kenya, living in DC. Sharky Ferns in US. MW Mario, Kenya. Ben Yu, Nigeria, living in Maryland. This is incredible. Chameleon, fantastic. Doreen's coming from Virginia. Yes, I'm 7. Yes, I thought I recognized your name, and I'm pretty sure we spoke yesterday. Lighten DV1, thanks, Real God. Love you guys. It's fantastic. Thanks so much.
Hey,
I have a good friend from
we have some actual questions if you'd like to take them.
Yeah, let's take the questions. Let's do anything.
Okay. Are you watching StreamYard or are you watching YouTube?
I've been watching YouTube, but I'm going to watch StreamYard so I can actually see it and not squint and look like this to the phone.
Right, and it delays you when you're watching the YouTube. So when I put them up, you don't see them. So give me just a second. There you go.
Can you explain the journey from entry to cloud architect as you're an ex-bootcamp student? Okay, so here's the thing. There's like the normal world, and there's like the way I've done things my whole life. I don't do things the way normal people do. Many people were told me in the beginning, you got to do help desk for a year or two, and then when you're done help desk, you got to take this junior network thing, or work in computers, and then work in this junior network role. I don't do any of that. What I do is I work really, really hard, and this is what I do for my students, really, really hard, to be so good that the hiring managers can't hire them. There are no rules. I'm going to say this again. There are no rules. My first job was a senior network engineer. First job, And my next job was a lead network architect within 6 months of the time that I decided I was going to study Cisco networking. I was then a lead architect on Wall Street 6 months later. So that was me. Now I got to also tell you this. I have trained countless people over the years, over the last 20 years. None of my people ever started out with entry-level jobs. Not a single one. Not one. So here's the secret to getting these jobs when you're new. And if you want to watch today's video, I had Christina Mariano. Christina is one of the best and most successful recruiters I know in the entire world. She maintains a team of 20 recruiters in New York. She has a staffing thing where they could hire all you guys as cloud architects and she could bill you out to other people, or she could place you in everything from AWS to Azure to the world's largest banks. She gets people placed that don't have experience too. So the key really is when you're dealing with this, you need to be really technically competent. Really technically competent. You need to be the most likable person in the room. You need to have extreme levels of emotional intelligence, extreme communication skills, empathy, enthusiasm, and all of it. So all of it. You need to be able to do ROI modeling. You need to be able to do sales. These are architect skills. So I've had people that worked in sales that went straight to AWS. I had a student that was born in Lagos that came to America that was in my program for 3 weeks that got hired via AWS. What do all these students have in common that skip entry level? Actually, I had another Nigerian in the UK that did it. I also had a sales rep in the UK that did it. I have a Jamaican buddy in the UK that just did it under our training. Every one of them showed up for class constantly. Every one of them worked really hard. They all built their own clouds. They all set up server virtualization. They all work with containers. They all focused on executive presence communication skills. They focus on all of it. They don't focus on anything unrelated. So they're not studying sysops. They're not studying DevOps. They're not studying coding. They're literally laser focused. They're like this. Is this related? No. Trash. Is this related? No. Trash. Is this related? No. Trash. Okay. The day has 24 hours. I'm going to work hard 4 hours a day, 7 days a week on this. That's how I did it. That's how people like Alonzo become great cloud architects. It's how people like Chris become great at what they do. We work really, really, really hard on these things. So, Chris, you want to grab the next question? Still, big companies have fear to migrate their data. What's the reason behind this? Well, generally speaking, it's not that organizations have any fear of taking their data to the cloud. Organizations have what they know it's actually working. And you really need to think about the cloud holistically. The cloud isn't necessarily better. It could be, but it's not necessarily better. If you have extreme performance needs of low latency and high speed, you can't do it as well in the cloud as you can in the data center. And you need to be aware of that as a cloud architect, and you've got to not try to migrate those clients. The next thing is, what kind of a migration are you talking about into the cloud? Are you talking about refactoring an org company's applications and going all serverless and cloud native? I got to tell you, 99% of the companies in this country will say no way to that. Why will they say no way? For the following reasons. We've all had interactions with the cable company. We've all had interactions with the phone company. They give you discount rates for the first year, and when you're there, they jack up your prices. If you go serverless on the cloud, and the cloud provider raises your rates, you have no choice. It could cost you a lot of money. So Solyndra, it could cost you $50 million or $100 million, literally speaking, to rebuild your applications to move them to the cloud. And should it not work on the cloud, it could cost you millions or hundreds of million dollars to come off of the cloud. So what most organizations are doing is they're taking a step approach. They're doing what's called lift and shift. They're taking their virtual machine from the network in the data center, and they're migrating to the cloud, which is just a virtual machine network in the data center. If that works and they're comfortable, then they're gradually having more things. I will tell you this. I have not consulted with a company in the last 5 years that didn't have plans to go to the cloud. Not a single one. All of them focus on it, but it's up to you. Remember I said this. The cloud architect is not such a technical person. Half technical, half leadership. You need to be able to interact with that CEO. Ask those business goals, legal goals, regulatory environments. All of it you got to be able to do. Then You've got to be able to solve business problems with technology. Then you must convince the customer they need this. So if you don't train sales, and you don't train presentation skills, and you don't train executive presence, and you don't train emotional intelligence and CXO relevancy, here's the thing. You can't be a cloud architect. So you're a cloud engineer. And a cloud engineer is a really great, really smart person. But if you're interacting with clients on the cloud and they don't want to go, change your tactic or realize it's not right for that client. So here's the key. If I meet with 10 clients, I'm going to tell 3 of them not to go to the cloud because it's not in their best interest. I'm going to tell 1 of them they have no choice but to go to the cloud. I'm going to have 3 or 4 of them that I'm going to do a hybrid cloud, and 1 or 2 of them are going to do a multi-cloud solution. Vendor lock-in is a nightmare, and everybody's afraid of it, and they should be. Some organizations are also afraid. One of the companies went cloud native, put all their things in a cloud provider. The cloud provider said, we don't agree with your business. They closed them down. The company went bankrupt. So since this, everybody's going lift and shift. Everybody's petrified of cloud native. We CEOs think about what happens. I think if I get hit by a bus, who will make sure my students graduate every single day? I think about if I were to die, Chris, my COO, is going to be able to, how can he run what's going on? Is it Chris? Is it Alonzo that are going to run this company? You know, these are the things that I think about. Chris and Alonzo, could they run this company for me? Could they take care of my students? Could they get everybody hired? Could they work with Christina? Could they work with their recruiters? This is what I have. So when a cloud provider kicks a company off the cloud and makes them go bankrupt, every CEO like me says, whoa, I run an OpenStack Ansible cloud. That's where we host everything on an OpenStack Ansible cloud that we built. I love the cloud. I have a cloud. So do you need college? No, but it helps. It's like anything else. If your knowledge is good, your communication skills are good, your attitude, energy, enthusiasm is good, no one can stop you. But everything helps you along the way. If you have a bachelor's degree, it's better than if you don't. If you have a master's degree, it's better than you have a bachelor's degree. Do you need it? No. Do you know what my degrees are in? My first bachelor's degree is in nursing, my master's degree is in nursing, and my second master's degree is in business. I have no degrees in tech. No one cared. I was the lead architect for a billion-dollar industry at one of the largest tech companies in the world. It doesn't matter, but you must have the knowledge and the skill and be great at what you do. Any others, Chris? I know somebody kept asking a bunch of questions and said it was important.
I didn't say it was. Somebody said it was important, but they didn't ask it.
Okay.
Here we go.
The book that I typically recommend on emotional intelligence is written by Daniel Goldman and Richard Boyatis. They were the 2 that coined the phrase. I have extreme amounts of training. I've spent more than a Mercedes on just emotional intelligence training because it's so important to your career. I will tell you that the Daniel Goldman and Richard Boyatis training is a book is a great place to start. Jeremy Wright, would it be best to learn how to cloud architect properly? Yeah, I think you don't have no choice. I think that, here's the thing. For people like Alonzo, for people like me, these AWS exams, they're silly easy. And why are they silly easy? First, we know how to design the architecture. And then we understand what the technologies are. So Alonzo knows what a NoSQL database is. And because of that, it doesn't matter if he's on GCP with Cloud Bigtable, AWS with Keyspaces, AWS with DynamoDB, or set up an EC2 instance with MongoDB or Apache Cassandra. So learn how to architect. In fact, when we train students, Jeremy Wright, every one of our students graduates with a certification because we have to have something to help on the resume. And they all graduate with a certified solution architect professional, and we provide the training. But we teach them the network in the data center first. The certification should be the after the fact. You should know what these databases are. And the certification should just be, oh, DynamoDB is the Amazon branded serverless NoSQL. So yes, Jeremy, we teach people how to cloud architect first, and then we teach them the certifications. But we're doing the certification free for the following reason. Not everybody can afford our training, though we keep it low cost, even though we could charge 25 times more and still sell it. But do the both at the same time. That's how you're going to be great. Learn the network, learn the data center, learn the cloud, and then do your certification all at the same time. That's the way you train doctors. They learn multiple things. They learn pharmacology as well as how to assess patients at the same time, and pathology. Do it the same way. It's all parts of the same package. You'll be great, Jeremy Wright.
Give me just a second. It scrolled up. Oh, here we go.
Great question from Farhara Naz. Is the cloud going to be there for the future? Well, here's the thing. I look at careers. I look at supply and demand curves. Right now, the cloud is in its infancy. Less than 20% of all major organizations are actually on the cloud. In the next 10 years, we expect 80% of them to be all on the cloud. Now, generally speaking, we look at supply and demand curves. So if all of a sudden there was a shortage of C# programmers, what would happen is everybody would get C# certified, everybody would learn C#. A year from now, there'd be a surplus of C# programmers, salaries would plunge like a stone, and nobody would get hired. Now the cloud is different. The cloud is what you call a disruptive technology. Here's what a disruptive technology is. Something that's new and innovative that changes things so dramatically, it changes our way of life. That is the cloud. So what's going on is right now, we're at the infancy. I say we have 10 years plus of just taking our current customers and moving them to the cloud. It is so hard to hire a qualified cloud architect that, literally speaking, if you actually find one on an interview, you can't even let them leave the door without making them an offer, because they will be hired by 3 other people within 3 days. It is that easy to get hired when you're qualified. I get 3 potential people reaching out to me a day, every single day of the week, and I don't look for it. It's because people know my brand. So there are so many jobs for cloud architects, so many jobs for cloud engineers, so many jobs for DevOps engineers, and with the future of automation, DevOps is going to be for the row. I predict that data science will be there for the long period of time as well, because we're gathering more and more data, and we want to do something with it to make better decisions. Cloud architects, cloud engineers, I think you have more career runway than you can think about. I would suggest you learn that along with the networking at the same time.
And for the next one, I already have some links ready.
Would a video about the business side of cloud architecture be off topic for this channel? The answer is no, but it's not a video. It's about 500 hours of video. And that's what we do in our cloud architect career development program. We realistically need to give you greater business acumen than you would have with an MBA, plus CXO relevancy. And I will tell you, we teach things that I did after my MBA, about $250,000 of training after the fact, I think. Those are the kind of things we go into. So it is way, way, way above something we can put into a simple YouTube video. That's what we cover in our cloud architect career development program.
And I just put the link to the business acumen for our cloud architects.
Okay.
Video.
Yeah, that's one that we did. It's a basic one, but it's still something that you can work with. And no other channel on YouTube will teach this. So
yeah, he asked about the channel specifically, so I was like, well, here's one on our channel. Okay. It's right up our alley. That's our whole.
I think there's a resume one on our channel as well, and lots of the mistakes where solution architects make mistakes, things that keep themselves from getting hired. Like today, I had a really nice person reach out to me. They thanked me for everything they did. They said, "Is my skill enough? I'm pursuing a DevOps career." And I say, "Look, I love DevOps, but if you get a DevOps certification, when you try and apply for an architect position, people are going to see you as a DevOps engineer. And once they see you as a DevOps engineer, they will no longer look at you as an architect. You're going to need a complete and total rebrand." So sometimes the biggest thing that I can do for you is the following. Make sure you only get the right certifications. The right certifications build you the right brand. Do you want a doctor that went to medical school, or do you want a doctor that cut grass for the last 20 years? You want the doctor that went to medical school. When if you were to buy a $1 billion airplane, do you want an airplane mechanic to fix your thing? Or do you want someone that's been working in sewing, that also studied DevOps, that also studied maintenance, that covered how to wash your cat, that's now flying an airplane? Of course, you want the person that trained for it. So get certifications in your career. not other people's careers if you really want to build a good career. Heck, rather than in sticking to a single public cloud, the approach adopted these days by enterprises to go for hybrid. It's all hybrid and all multi-cloud. There is no such thing as just AWS anymore. It's all hybrid or multi-cloud. I love the Nutanix solution. Take your data center, turn it into a cloud, get all the auto scaling. I love the IBM OpenStack Ansible one, the Red Hat one, the Ubuntu one. I run an OpenStack Ansible cloud personally. I don't use an external cloud provider because I can run my cloud better, faster, and cheaper than the cloud provider. So I love this, love this, love this. Everything is hybrid cloud, multi-cloud. That's why we've talked about the Google terms and the AWS terms, and we've said learn to drive a car instead of learning how to drive a Honda. Completely agree.
All right, Mike, I have to be the bad guy now.
You have to be the bad guy. I'm not allowed to answer anything. Okay, so.
Well, you have to plan for more. They want more. So you have to have time to plan for more for them.
Okay, fair point. Well, if we have a captive audience that wants to learn, are here to learn, I want to do everything I can. Now, I can't stay much longer because we already ran 35 minutes, but let's make sure we give them 5 more minutes, Chris.
Okay. See, I build that in when I give you the warning. It's like, I'm already prepared. I got the 5 minutes in my back pocket.
So Chris is my chief operating officer, and I don't even know how I would survive without him, and I need him to tell me what I can or can't do. Virtual Circuit, the next time I come to London, I would love to have dinner with you. I used to be there every week, but it's been a little bit of a while. I had a really bad accident, which kept me from jumping on airplanes. Sometimes when I travel, I have to go to the operating room to open up blood vessels in my leg because of the bad injury I have. But I'm going to be traveling soon because I need to, and I have to get to the UK, and I would love to meet with you. Harish Sina, can you share any specific skill sets to focus on, like Cisco Packet Tracer? Because you're from a non-technical background. Sure. Here's what you need to know. And this is what's in our Cloud Architect Career Development Program. I need you to read. If you're not in our Cloud Architect Career Development Program and you want to know, and our program is the cheapest and fastest way to get here. If not, buy the book, Internet Routing Architectures by Bassam Halabi. Buy the book, Routing TCP/IP from Jeff Doyle, volumes 1 and volumes 2. It's about 5,000 or 6,000 pages of reading, and that will give you the fundamentals of networking, but not all of what you need. I then need you to learn NAT. I then need you to learn spanning tree. I then need you to learn VLANs, 802.1q tagging, 802.1x, QoS, just to name a few and things. I need you to be that expert on those routing protocols, which we talked about, because they're also important. Then I need you to understand and learn encryption technologies, private lines, link aggregation groups, port aggregation protocols, unilateral link down problems with regards to fiber optic connections, and the types of squashes, as well as how you architect the systems, core, access, distribution layers, and such. That is about 10,000 pages of reading, and that will give you the fundamentals of the network. Then on the data center side, and by the way, this is why I say there's no time for DevOps and no time for SysOps, because we're going to talk about at least 20,000 pages of reading to be job ready. Of course, we teach this in our program. We make it simple for our students, but if you're not in our program and you want to do it for free, I'm giving you the free way. Next, I need you to learn server virtualization. So go to the VMware website. Read about 500 pages, 1,000 pages of server virtualization. Do the same thing for containers. Go to Docker, go to VMware, go to Kubernetes. And again, for about 1,000 pages of reading, you're going to know how all this stuff works. It's not for an architect how to configure it. It's how to design it. You can't design what you don't know. Then Linux. Start learning about Linux. Read some Red Hat Linux books. They have great documentation compared to other Linux providers. Then learn about firewalls. Go to Cisco, Palo Alto, Juniper, Checkpoint. Learn about firewalls. For about 1,000 pages, you'll get there. Do the same thing for IDS and IPS systems, intrusion detection, intrusion prevention systems. You're there. Now, learn about IAM. Learn about Radius servers. Learn about Microsoft Active Directory. Again, about 1,000 pages will get you there. Then learn about the cloud. Better yet, build a cloud. All my students do. Get yourself a server with 16 cores. Every one of my students does. Build an OpenStack Ansible. Build a cloud. Once you built a cloud from scratch in a data center, you know the cloud. So you can't design or architect what you don't know. So this is the minimum level of technical knowledge. Now, still, you need to learn executive communication skills, executive presence, presentation skills, writing skills, speaking skills. Trust me, all this is feasible. I do it constantly with people. In 16 weeks for people that have a little tech background, and 6 to 8 months for people that don't. But we've got a system for teaching it. And if you're with us, it's simple. And I've got lots of students here that can tell you their great experience. Like Alonzo, he came through our training program. That's why he's such a great cloud architect. But in today's day, he's rock solid, rock star, and he gets requests constantly because he's so good. But it's about knowing all of those things. It's not about being great at configuring it. It's not about getting 20 certifications. It's not about sysops. It's not about DevOps. It's not about any of it. It's all about architecture. So I didn't mean to give you such a dissertation, but you asked some questions, and I wanted to make sure that you knew that. Any others, Chris?
Mike's still on. Yes. So you answered it in that question, but someone asked, would you recommend an architect student to download Linux?
Yes.
Yep. Someone said that they'd be interested to join, so I'm going to post the link to the to our enrollment page.
Yeah, post a link to the enrollment page. Post a 20% coupon. We want to give everybody, make it like, and that way it brings our entire training program to a single day's pay they would earn as a cloud architect, because we want to help people in their careers, not hurt them financially. So and if anybody's got any questions about our training program, I'll put in our corporate office phone number here in the chat box, which is a crazy thing to do on YouTube, considering we get 100,000 views a month. But you know what? We're here for you if you need it.
So why does a data scientist learn about the cloud? Not answering that one. No. Mm-mm.
Do you want me to answer it? Why all the data scientists have come to me?
Yes, you can answer it a lot better than I can.
Okay.
I mean, no, the immediate answer that I would give is because the cloud has so much computing power to be able to do all the data science, all the machine learning, and all the data science under the hood.
Yeah.
Like my computer that I run models on is nothing compared to the cloud, and even the computers in data centers sometimes can't, especially with platforms like Google. Like there's no way to get anywhere near the capabilities of what's possible on the cloud for the cost that you can get on the cloud.
Yes, and I'll give you the other side of it. You can do all these things in the data center in a great way, but you're buying a whole bunch of Quadro GPUs from NVIDIA, which again might actually be cheaper if you're running these systems 24 hours a day. But look at it this way. Look at Google. What does everything Google do? Search, right? Advertising, matching up advertisers with users based upon information. To run the world's #1 search engine and the world's #2 search engine, which is Google, they've got a lot of AI machine learning capabilities. So over the last couple of decades, they've got a lot of these things and frameworks that are pre-built. So because it's pre-built, you can use a lot of their libraries instead of having a data scientist do it. Now, I'm also going to tell you this. A lot of it's done in the cloud. But I've also had an influx of data scientist students. And the data scientist jobs are among the hardest to get out there, especially if people don't have PhDs in mathematics and other things. Because they're so hard to get, people are coming to me because they know if they can become a cloud architect that also has a big data background. And what we do then is we can make them the cloud data architects. We teach them cloud architecture, and then we marry that with the things that are necessary to do the data science, that people can get really great cloud data science careers. So very hard to get these jobs in data science. So a lot of the data scientists that have come to me, and I've had about 4 or 5 at this point, have all come to me to help them get hired as data scientists because it's so hard. But a lot of these libraries are there. And, if you were to buy a good server and you bought 5, if you put 6 Quadro cards in a server, each server is about each really high-end card is about $5,000. It would cost you about $80,000 for a really high-end server that's got enough PCIe lanes to the system. Now on that, it might be cheaper to run in the data center. Or If you're running them sporadically and you need to just do big batch jobs, the cloud's going to be a lot cheaper, especially because you don't have to make the libraries because they're already pre-built. I don't know if I have time for any more, Chris. It's up to you.
Well, we have other schedules, but that's you're on the flow.
Okay. Well, I think we've got one more, which is from Chintan, regarding Chintan's answering someone's question whether they should download Linux. Yes, download Linux, and if you really want to be great at Linux, and if you really want to learn it, I'm going to give you the Linux therapy option that I have used with my students for the last two decades. You know what my recommendation is? It's free, by the way. Take your everyday computer that you're working with, erase Windows, and immediately install Linux. Do everything in your life in Linux. Install all applications via the command line. In 6 months, for no cost, you will know Linux. Because every time something breaks, you're going to have to Google it, and you're going to have to read the documentation, and you will know Linux. I've taught more people Linux that way. And the last question from Brendan Fraser, like the actor, are most architects on call? Look, we're not going to be on call like SysOps people. Remember, SysOps people are maintenance people, and they get called at 2 o'clock in the morning. The systems are down. That is not us. But, we work from home. We deal with lots of clients. Are clients going to call you and ask questions? The answer is yes. If a client has a big outage and you're their architect, they may call you for guidance. So the answer is yes. Are you on call? No. Do you get phone calls after hours? Sometimes you do, but you just have to do everything you can to do the best you can. I will still tell you, being an architect is the easiest job I've ever had. It's about 1/8 of the work of an engineer for double the pay, maybe half the work for double the pay. I absolutely love it. It was the best thing I ever did, and I can recommend it to anyone. I agree with you, Evo. I love Debian, but I'm partial to Red Hat because that's where I started. I use both.
And Brendan Encino Man pointed out we've got some mistakes on our website. Well, a little humility. Me and Mike are human. It's just me and Mike.
We do have
Mike
some things on our website.
Mike and I, that's it. Our grammar is not the best.
And Brendan Fraser, I think you'll be 3 times happier and earn double the salary long-term in architecture for half of the work. That's what I can recommend. I still think DevOps is a great career, but if you like to be in front of people, much more options when you're closer to the money. And architects are closer to the money, which is why they get paid so much more.
Yeah.
Okay, Chris, I think I ran 15 minutes late, and I did it because I love you all out there. It is such an honor and such a privilege to be able to speak to so many wonderful people across so many continents. So, yes, we do have lots of spelling errors that we're working on. Brendan, thank you for this. It is important to us.
I put my email address in there.
If you find them, please tell us. I just hired this really, really great, super smart guy, Jesse. I'm also hiring somebody from AWS in the next month. So when these folks join me, we will actually have the time to actually really fix some of these things. We're just 100% dedicated towards our students. And because of that, that's the kind of things we do. Maybe I'll get to the last one, which is Harris Sinez. Can I tell you about availability of job titles for entry-level positions? Here's my perspective. Entry-level jobs are gone right now. And you don't need to have them. Here's what happened with entry-level jobs. First, we had COVID. COVID basically made all the companies lay off or fire everybody that's not one of their best. So, because they can't afford to pay people. So the next thing that actually happens is if you hire a new person, what do you hire a new person for? You hire them to rack servers, to plug them in, to screw them in, to unbox them, to install an operating system. Guess what? We don't do that anymore. It's not on the cloud. So all of these fresher roles they kind of don't exist anymore. So the key is, and you can do it, is be so good at any job you want that you don't need an entry-level role. So I look at it as a solution architect as an entry-level role. I look at it as a cloud engineer as an entry-level role. A lot of my people that I train to be cloud architects, often they have to go down and become solution architect roles, which is almost the same thing if they have no experience. But you know what? If someone's got a great solution architect role for a year later they get a cloud architect role, they do that for 2 years, they pick up an enterprise architect role, wow, they've got a great career. So I would say consider your solution architect or your cloud engineer role entry level and fight to be so good that the world can't not hire you.
I think that's a good note to end on.
I think that's a good note on. All of you can do anything you want. The only thing stopping any of us is our own mind. Watch what people can do. It's amazing. So Instagram's down again. There you go. So.
Oh boy, here we go.
So
that's just the beginning.
And this is just the beginning. So this is why you ask me why I say don't get 10 certifications. Be great at what you do. I've spent 10,000 hours on just BGP. I don't make these kind of errors because that's all I know. Now, if I knew BGP and I knew this and I knew this and I knew this and this, I'd have a little knowledge about a lot of things. I wouldn't be able to find it. Yes, cloud architect jobs are becoming very, very common. Is remote available? I've worked remote for 20 years. So yes, absolutely. Oh my God. I've never thought of myself as an influencer before, but you know what? Maybe there's something to be said for that. And you know what? I am checking my phone 20 times a day to check in on messages. So I guess I have become a little bit like that, but it's all out there for you. Chris, we have to close this down. I know we've got a lot of work. Alonzo, thank you again. Chris, thank you again. And
Mike said it this time, not me.
I'm behaving. I'm being good. I have to respect your time and Jesse's time.
All right. Well, I'm going to click the end broadcast in 5, 4.
Please like and subscribe.
2.